Move it above the operating system. Leave the operating system out of it. If they want to do age verification, we can create an application that runs on the internet that handles all the age verification. Leave the operating system out of it, right?
Well, you can do that until the people storing all the IDs get breached.
You can have that problem anyway. Any problem that they can bring up about breachment and stuff, and plus the fact that if you do it right, the only two things that are actually in that service is an identifier of the child and the age of the child, okay? You throw away all the other information. Throw it away. Don't hold it any place. And then when the breach comes, you don't get anything, right? I've written a large white paper about this, and I've sent it off to people who should be able to do this. The same thing happened after 9/11 when they tried to take away encryption again. I wrote a long paper and sent it to Judd Gregg, the senator who was working on it, and 2 days later he dropped his bill.
You sent a paper to California about 3D printers?
Yes.
It's a little late for here in Washington.
I'm 75. I shouldn't have to be writing this type of crap. I should be able to sit in a hammock, in my house. How's the time going?
I got one more.
One more minute. So this will be the last real rant I'll give during this talk. And I'll have a couple of little rants later on, but
Is the age verification push just for data collection instead of protecting kids?
some people think that is, and if that's the case, it's being pushed by Meta. And I think that one of the reasons why they're pushing it is to reduce the stress on them of doing what they should probably be doing themselves, okay? They're just deflecting the issue. Now we're done. Okay. Hello. My name is John Mad Dog Hall, and I'm the president of Linux International. I'm also the board chair emeritus of the Linux Professional Institute. That last one, and $350 will get you a cup of coffee in Starbucks almost any place. And lately, I've been the open source advisor to a company called Q Sentinel, which we'll hear a little bit more about later. But who am I really? I started programming in 1969. I've had a wide variety of different jobs in education and stuff like that, and worked for Digital Equipment Corporation, where in 1994 I met Linus Torvalds, saw Linux for the first time, and said, best thing since sliced bread. And since that time, I've been traveling around the world to over 100 countries, most of them more than one time, spreading the word about free software in particular and open source in general. But most of the thing I'm most proud of the fact is I'm pragmatic. I like to get the job done, okay? And, I don't spit on people to use Apple products. I do spit on people to use Microsoft. So who am I really, though? Like I said, I've been programming since 1969, IBM 1130 in Fortran, spelled with all capital letters, only had an arithmetic if, not a logical if. And I met Richard in 1986, gave him his first VAX computer system running Ultrix so he could port the GNU tools to it. And I've known him ever since. And if you get me drunk enough, I will tell you lots of stories about him. In 1994, I met Linus Torvalds, saw Linux for the first time, and decided that this was something that was really good, and arranged for him to take it from a 32-bit system running on Intel to a 64-bit system running on Alpha, a RISC processor. And after that, I started promoting Linux around the world. In 2012, I dropped something, rats. Oh, it's there. I gotta pick this up before I step on it. No, it's that little dot down there. Oh.
You got it. I got it.
She's got it. Okay. In 1994, I went to Brazil for the first time and saw the University of Sao Paulo, 100,000 students, 16,000 PhDs, and got involved with them. And then in 2012, I decided to help them build their own computer, design and build their own computer. And it wasn't just designing and building the computer, but it was setting up supply chains and manufacturing and ways of promoting it and stuff. They used ARM architecture in the beginning. They're now switching over to RISC-V, and they're designing their own CPUs. Not only this type of computer, which is a lot like a Raspberry Pi, but this type of computer, which is using an ARM M4 microprocessor, and this is a sensor computer. This can run for up to 6 months on a watch battery and senses information, transmits it via Bluetooth, Wi-Fi, or LoRaWAN to something like the Labrador, which I showed you. The reason we were doing this, because back in 2012, I started to get really nervous about supply lines and stuff of China and Europe and even the United States, even though I didn't realize it was going to get this bad. And, so we started doing that to give sovereignty to Brazil and to Latin America. I have been a Bernie boy since 2015. I'm actually to the left of Bernie, so now you know what my political leanings are. And I've been to over 100 countries, most of them more than one time. I, by the way, am married to a Brazilian. He is the love of my life and really great king. So, with all of that as introduction, we're going to go into what is, sovereignty. Now, a king is a sovereign. King says what to do, where to farm, they own serfs and stuff like that. They tell you when to get married. And that skill was later transferred to the church. That was a big mistake. Henry VIII realized that, okay? And they make and execute the laws. That's a sovereign. The serfs own nothing. But in the United States, we had our own serfdom, the masters and the masters owned everything, and the slaves had nothing. And they told the slaves what to do, when to marry, when to eat, when to live. And they even sold off their children and other stuff, and the slaves owned nothing. Now, closed source companies are our masters, right? Well, not our masters, but the masters of many people. They tell you where to put your software, when to upgrade the software, how many people can use their software, when to retire their software. Can anybody say Windows 11? Okay. And closed source users are software slaves. Now, open source is actually not any better, because with open source, what they say is, we'll show you the source code that generally is what made your product, so you can see how it works, and you can see, you can start with that, you can make other things, but there's nothing in an open source license, what we call a permissive license, that forces the user of that software to make that source code available to the end user, okay? So they can take the software, make minor changes to it, add their secret sauce, and then create a binary and give you the binary, and that's what you buy. And you cannot reproduce that software that they gave you because you don't have the actual source code, nor the method of actually making it. What compiler did they use? What build system did they use? So forth and so on. So to come up with the same bits that they gave in the binary is practically impossible. So the end users still can't change the binaries. And so many of the detriments of closed source still exist. Free dumb software is the path, Richard Stallman says the biggest mistake he ever made was simply calling it free software, because everybody thought that was the same thing as gratis software, right? And he never meant it to be gratis. He said, hey, you should be able to make a living selling and making free software. You just have to have the right business model. So, but free software allows you to put that software in any architecture you want to. So the people that are building these Caninos Lucas things I showed you earlier, they're now moving over to RISC-V. Why? Because with RISC-V, you don't have to pay the ARM Corporation $500,000 for a license to start off doing stuff, and you don't have to pay them a per CPU royalty or stuff like that. The University of Sao Paulo has already taped out their own RISC-V processor, and they're making the equivalent of the Arduino, but with RISC-V instead. And they also took the Arduino IDE and made it generate RISC-V instructions. And they've also taken all of the little hats that fit on the Arduino and put them on their RISC-V Arduino. I'll probably get in trouble for saying that, trademark law. But all the hats work too. So you can take your source code that you stick into your Arduino IDE and stick it into the RISC-V IDE, and it will work. So that's very important. And this allows you to upgrade the software when you want to. It allows you to put as many users on the software as you want to put on, okay? And even if you don't have the expertise, people come along and say, oh, Mad Dog, I don't have the expertise to do that. I can't write a program. but you can hire somebody who does. And therefore it becomes back to a business decision that you have of staying with the hardware the way it is, or the software the way it is, or hiring somebody to make it do what you want it to. That's a business decision. Now, business people really hate the word freedom. I don't say freedom to any more than business people. I don't say freedom because it scares them to death. Freedom means that you can go, as a customer, you can go off to another supplier. Where freedom says, all these things, they hate the word freedom. But what they love the word is control. You have control over your business. You don't have to wait for this company in Redmond, Washington to make a decision, or this company in Cupertino. I don't want to just pick with Microsoft. This company in Cupertino to make a decision to change the software to what you need. You can do it, right? And they love that. They love it. So all of you who've been going out talking about software freedom all this time, talk about software control. That'll get them. So now we come back to sovereignty, okay? And as you might guess, Donald Trump isn't my favorite person. I've been following him since 1969. There's a reason for that. And so I really didn't want him to win in 2016 or 2020 or 2024. But unfortunately, the people I wanted didn't win either. And also, unfortunately, he has shown that you can't trust this administration. Even if you agree with some of his policies, you can't figure out what policy you're agreeing with and then whether he's going to be having that policy the next day. And so this has allowed a lot of people, particularly over in Europe, to say, we're going to move away from some of these companies in the United States who Donald Trump says something to them because of the Patriot Act or one of these other things, and they have to do it. They can either not do it and go to jail, or they can do it, and this affects these other countries. And from my viewpoint, he's allowed the oligarchs to take control. If you have enough money, you'll be able to buy whatever you need. And so it's the rest of the world now sees sovereignty as being separate from the United States. Don't buy stuff from the United States, right? On the plane out here, I was listening to a news broadcast about how Canada has stopped buying liquor from the United States. The whiskey industry in the United States has gone down 30% because Canadians stopped drinking American whiskey, and particularly bourbon. And that's hard for some of my friends in various places around the world. So, but U.S. citizens also need sovereignty, right? We need to be in control of our own lives, our own data, our own software. We need to have sovereignty. And it's not just the sovereignty of the data. I mean, for a long time, AWS and Google and stuff have said, okay, we'll put servers in your country, and therefore the data will stay inside of your borders. Now, if you believe that, I have a bridge to sell you in New York City, because it doesn't work that way, okay? Not unless you take a lot of time and effort to make sure it works that way, and even then, it's hard, okay? But it's also the sovereignty of the networking. Where does your networking packets go? Do they all go through a certain data center off the coast of Ireland? They're open to anything. And people say, well, that's okay, I use a VPN. I got more bad news about that in a moment, okay? So you need also the sovereignty of technology, because you have to start training your kids from grade school in how to have sovereignty, okay? And when they come to technical college, you need to train them in sovereign software and be able to make sure that when push comes to shove, we can maintain our own systems, okay? The users need control. So quantum computing, before some of you came in, I was telling you that there's several things which I hated. I hoped I could retire or maybe die before I had to worry about them. One of them was quantum computing, one of them was security, one of them was deep dive networking. Quantum computing, I'm stuck with it. And quantum computing is coming. And for those of you that are not aware of the fact, our wonderful RSA type of encryption that requires 2 prime numbers can be broken in about 15 seconds by your average off-the-shelf quantum computer. And therefore, you may be using your VPN in the airport, and while you're logged into some system watching porn from another country, the quantum computer can break into that VPN while you're using it and insert itself in the middle. And this is going to come. And we used to say it was 10 years, and then 5 years, then 2 years, and it's going to happen, folks, very soon. So, if you're encrypting data on your system, NIST has already published some encryption algorithms that are quantum computing resistant. I'm not going to use the word proof because I've been in existence too long to understand that there's no such thing as a proof thing. But using brute force techniques, it would take thousands of years for even a quantum computer to break this. Learn about them. Some of the major distributions like Red Hat and SUSE and stuff are already making them available to you. Take your data, all of your cat pictures that I know you've encrypted with 4096-bit encryption with RSA, re-encrypt them with these algorithms to protect your cat pictures from being used, okay? And we thought, okay, quantum computing, long way off. Well, that's what we thought about Y2K. Before we knew it, it was here. And we had a panic mode where we hired all these COBOL programmers. I'm retired, doggone it! Well, you're not dead. Come back and program. But it may be too late because people breaking in, they're harvesting the data that's encrypted with RSA, and they're holding it, and they're going to sell it to data brokers and decrypt it when quantum computing comes in. Okay? It's happening. So now is the time that you really need to start encrypting your data before somebody breaks in and takes it and can decrypt it with quantum computing. So, and this like as I said, this goes with VPNs too, okay? So when you start looking at cleansing a cloud, you have to think about what cloud are you using, under whose laws are you using it, and what is their supply chain? Where do they get their operating system from, and where do they get their chips from? And they go, oh, Mad Dog, chips, what are you talking about? Well, you know something? Those little Intel chips we all use, or at least some of us use, those little Intel chips, they have something in them called microcode, okay? So for every assembly language instruction, every instruction that you can see as a programmer, there's hundreds or even thousands of tiny little instructions there which can actually be changed to put in malware. And they're invisible to you unless you actually go through and time the CPU under different situations to force it to execute that microcode with the malware in it. And so this would be invisible to the operating system or to debuggers or stuff like that. And you say, oh, Mad Dog, no, nobody could do that. That means that somebody actually took the motherboard that I ordered from this company, got it in mid-flight, unwrapped it, took out the motherboard, took out the CPU, and substituted another CPU with changed microcode in it. That would take a highly sophisticated person with billions of dollars at their disposal to do that. And so I will tell you, it's already been done, okay? And if you don't believe me, I will tell you about a pager that was produced in Israel that exploded 1,500 devices at one time in Hezbollah, killing hundreds of people and maiming even more. It can be done, it is being done, and this is just the tip of the iceberg, okay? So you have to know where your chips are coming from. And that's one of the reasons why the FCC has this ruling about, where supply lines on these routers that are coming from outside the United States. But the problem with that is that we have domestic terrorists, right? remember, what was his name? The guy that blew up the Internal Revenue Service in Oklahoma?
Timothy McVeigh?
Yeah, yeah. You know, he was homegrown, you know. You get somebody in there and says, hey, you know, I have something against the IRS. And we all love the IRS. Or, you know, something else. And they can be hired by somebody who can then put this malware in. So the problem is, it's not going to fix the problem. So, you know, you have to say what chipset, and then remember, we're a different country. We're Brazil or we're France or something. You have to know what company makes your chip. You have to trust them, okay? And you have to say, where is the fabrication plant that they're making these chips? And you have to say, where is the printed circuit board manufactured? Can we trust this multi-layer printed circuit board to do what we want it to? And where is the boot code created? These are all things that we really have to think hard about. And this is why today we have to use blobless freedom software. We have to look at where the compilers were that actually generated that software. How many of you have ever heard of Ken Thompson and the fact that he could become root on any Unix system he touched in a matter of seconds?
Really?
And when he did that, everybody looked through the source code for the Unix system and they couldn't find the trapdoor. They looked through it, couldn't find the trapdoor. Finally, Ken told him what he did. He put the trapdoor into the C compiler. But when you compiled the C compiler, the compiler took out that trapdoor and just left it in the object code. And every time the C compiler object code would recompile the C compiler again, it would insert the trapdoor, create the binary, and then pull the source code out again. So you could have looked at that code until the cows came home and not seen the trapdoor. So this is the level of, and that was years and years and years ago, and the level of sophistication has gotten even worse. But I recommend that we go to RISC-V architecture. Why? There is no microcode there. You can test every single instruction in the RISC-V instruction set in a day versus in a complicated instruction set computer, it could take a month to test every instruction, every data type, every indexing model, and so forth. So the RISC-V instruction is so simple that you can really, almost by inspection, see whether it is has trapdoors in it or not. But what we need are sovereign clouds, okay? You need clouds where you need them, and you need to have security first. So why do I say this? How many of you use AWS? I'm not going to ask you that, that's embarrassing. But if you use AWS or Google, right? Use Google. What's the first thing you do when you go to use your Google Mail? You log into Google, okay? You give it you give it your ID, you give it a password. Right? That means that there's an attack vector, at least one attack vector to get into Google Cloud. Because if you didn't have it there, you couldn't get in at all. That's putting ease of use first, not security first. Security first would say there's no way that you can log into Google Cloud unless Google Cloud already knows who you are. Okay? And that's a problem. You could also say the location of where you want them. Don't have your cloud in some other country. Have your cloud in your country, under your laws and nobody else's laws. And the software should be under your control. And you have authentication, which is open and secure. So we need an enterprise sovereignty. And the company I represent, Q Sentinel, and there's other companies do this. We've developed a cloud which is in a hardened data center in Switzerland. You can buy access to this data center. It runs on IBM mainframes under VM. It's highly available. When I started out, high availability was 3 nines. 99.9% available. Then it was 5 nines, then 7 nines. These data centers give you 9 nines of availability. That means that they're unavailable to you for 30 microseconds out of a whole year. I'm sorry, 30 milliseconds out of a whole year. Okay. And That's high availability in my viewpoint. We have NIST-approved quantum algorithms to do both the data encryption on the disk and also VPN. And it's open source from end to end. We use Nextcloud and things like Odoo for enterprise stuff, not, AWS, not closed source stuff. And we give end-to-end security, and we also have sovereign AI. What does that mean? If you use AI on this system, the input into the AI is not shared with anybody else. It is sovereign to you. So none of your information goes into these, is shared with any of the other people using AI on this system. And it's licensable to your own data center if you want to sell this to other people. Now, that's the enterprise stuff. And I know a lot of you people are not into the enterprise stuff and stuff. You like to do stuff in your home. So I'm going to tell you about a little project that was started back in 2010 by a man named Eben Moglen. And Eben is a law professor at Columbia University in New York. He's also the person who wrote GPL version 3. And about the year 2010, the hackles in the back of Eben's neck started to stand up because he realized that people were putting very important and secret things on these clouds and that other people might have access to them, and this really bothered him. So he started this project called the Freedom Box project. And what the Freedom Box is a very small and secure server that runs on something along the lines of a Raspberry Pi, maybe 3 to 5 watts, and you can plug it into your wall, and it has a dashboard which makes it easier to use. I didn't say easy, right? It's not mom and pop easy, but if you know anything about networking, you could probably easily set this up for mom and pop. It is a server. It's not really an end user device. If you look at the interfaces for the software to come on, you say, oh, that's an ugly interface, ugly, ugly. But see, you're not supposed to use it. Your client software is supposed to use it. That's where your user interface is. And once you understand that, then you understand the whole thing about Freedom Box, right? So it runs Debian, and all of the software for Freedom Box is in Debian. So if your system runs Debian, whether it be an Intel system or an ARM system or stuff like that, the Freedom Box software is already there, okay?
Just remember you have 5 minutes.
Okay,
And then-
I'm
and
doing
15
fine.
minutes Q&A.
And it also supports the Fediverse software on top, like Mastodon and Diaspora and stuff like that. So you could actually, if you put enough disk on it, you could actually make a nice community server for people to use, okay? Now, all of that is the server and stuff like that, but you still have to log into it. You still have to use that password or passphrase or stuff like that. Or maybe you're a little more sophisticated and you've got it set up so you use your fingerprint or facial recognition. I got so much hair on my face, facial recognition doesn't work that great. Or you can actually set it up for time and day oriented. If somebody's trying to log into your system and it's not Monday through Friday, 9 to 5, you say, ooh, that's not good. Or you use geographical information. That could be overcome by a VPN, but you could also work a little bit that if your device is actually some other place where it shouldn't be, don't let them log in. And you can use a hardware key. And so if you use a hardware key, like this one, you really need 2 of them, or maybe 3. You need one to use every day, and I have mine actually attached to my keychain that I use every day so I don't forget it. And you give the other one to your mother, who lives a long way away from you. So fire and flood and stuff like that is not going to destroy that. If you lose your one, you go to your mother, and if she's nice, she'll give it to you. That, by the way, is also the person that you set up to back up your system to. You give them a Freedom Box at the same time. You give her a Freedom Box at the same time. Her Freedom Box is backed up to your Freedom Box. Your Freedom Box is backed up to her Freedom Box. And only when you have fire or flood or something like that, you have to visit her and get recover your data. And it should be using a standard like FIDO2, which means that this key not only can be used on my hardware and my server and stuff like that, but if I go to a library and I want to be able to sit down to the library computer and log into my Google account if I want to, I use my hardware key and Google recognizes that and only lets me log in, okay? And it should be an open design. It should be open free software. It should be hopefully open hardware, okay? And that guarantees you not only if the company goes out of business that you can still get to your data, but a long life. So I am representing here solokeys.com. They have a completely open system. It's FIDO2 compliant. And you know, I've been working with the Freedom Box people that they're now supporting hardware keys with the FIDO2. You can use other keys with it, but to use this type of a system in the Freedom Box software. And you can use, I've implemented AppArmor on my system, and I have also taken PAM and implemented a lot of stuff with PAM. So you cannot log into my system over the internet unless my key is plugged in and I touch it. Okay? Other than that, you'll bounce right off. You can't do an SU on my system unless that key is plugged in and I touch it. Okay? So there's a lot of security there that can be done with these. And now we get to the raffle. And I have contributed a Pioneer Freedom Box to the raffle. Complete the hardware that you see there, the CPU, the memory, and everything. It's an all-winter chip, all-winter 20 chip. And I also have a disk drive controller there, not the disk drive itself, but you can take a 2.5-inch disk or SSD, put it in that box, and it has Freedom Box software already with it on the little micro SD card. You boot it up and start using Freedom Box. And I also included 2 USB-A solo keys that plug into the box so you can have hardware security at the same time. And all of that's in the raffle. I also contributed a Linux Live For Your Die license plate and also a nice carrier for your laptop and stuff. Those are separate items though in the raffle. So with that, I finished working on my slides right before I sat down here, so that sign is actually outside here. Forge your own path. Be sovereign, okay? Take control of your life and your software. Thank you very much. Do we have any time for questions?
We have 15 minutes for questions.
Oh, 15 minutes for questions. I thought I was out of time. Okay, 15. Yes, sir.
What's your current favorite laptop? Used to be ThinkPads or...
It's still ThinkPad, but it's with Lenovo. And I'll tell you the reason for that. Way before a lot of the and there's a lot of laptops now with modules and stuff that you can stuff, but IBM ThinkPad was way back when. And I got it because I have acid in my fingertips that actually eat through keycaps. So my previous laptop, I replaced 3 keyboards in the life of the laptop, you know, and I could just I didn't have to take them to anybody, I just pulled them out, replaced them. I could buy them for $25 new off of eBay, right? I started off with a 500 gigabyte disk. By the time I ended up, I had 3 terabytes of disk in it. I bought it with completely full of memory, so it was 16 gigabytes from the very beginning. So, you know, the previous laptop lasted me for 7 years, you know, and it was fine. The only reason I went to a new laptop, and it is a ThinkPad, was because the fastest USB port I could get for it was only USB 3.0. And when you have 4 terabytes of data in your laptop, as I now do, it's just too slow to back up, okay? So now this new ThinkPad has USB 4, and so I get 40 gigabits a second in backup. Sweet. Yes?
What's a facet of digital sovereignty for the everyday internet user that you've thought about more recently than say 15 years ago?
Well, the thing well, 15 years ago, we didn't have as much of a use of AWS or stuff. I came out in 2012, and the reason I came out was that that was the last secret in my life I had that people could blackmail me with. And by coming out, I have no more secrets of any type. But people do have secrets, and they have to watch for people who would gather information about them, or use your credit cards and stuff like that. So we have to really do an education of people, your mother and father and stuff like that, and talk about the security and the privacy and the sovereignty. Okay, because there are people, there are people that want to take away sovereignty of people, and we have to get people to fight back on that. Did I answer your question?
I did, yeah.
Okay. In the back, yes, sir.
Have you proposed or know of any solutions for mobile devices, for sovereign mobile devices? Because everyone has a phone, and we're really tied to Android and iPhone.
For actually, Q Sentinel does handle that problem. Okay, but so I'm going to use a real life example of this that everybody's familiar with. A few months ago, Pete Hegseth was there, and they were using the Signal application on their personal phones to talk about this ongoing thing. And they said, it's okay, we were using Signal. And all the security people around the world just went, oh, because, okay, the Signal app is secure, but what about the interface of the operating system of Android and the phone they're using? Has that been compromised? Okay. And the answer is probably. And so, you really have to think about the entire stack, okay? And so what Q Sentinel does, which is pretty amazing, is they create a quantum proof or quantum resistant VPN that goes from the server out to a known device. So you register your phone with it, you register your laptop, you register that, and it makes a tunnel that goes to that device. Now, if you're smart, you only use that device for one thing, and that's to talk to Q Sentinel, okay? You have nothing else on it, no apps going down it or stuff like that. You may have an app, it may have an operating system that was specifically built for that device. And then the only thing there is you now have to log into that device. And that's where you use the multi-factor authentication key, right? So this one has USB-C, but also has NFC on it. So I set it up for my Android device that only I can log into my Android device. Right? Now, as I said, I don't have much information that people would find useful to know about me, because everything is known already. So I use a stock Android device that I get from Google. Right? But if I was really paranoid, which I am, I could get a device that has been manufactured by somebody I trust. So, did I answer your question?
Yeah, sort of. It's just an issue that I see. We like free and open source software. We can have other people verify the code, but we don't. There's not a lot of mobile, like cellular, regular text messaging, other than these companies.
Well, there actually are replacements for Android on a lot of the older phones, and you can buy one of those, and those are all free software, so you could do your inspection if you want to. I mean, in reality, people aren't going to do all this, except if you're a government and you really want to have security and you have the money to invest in this type of thing. And then what I say is, if you're smart, you limit the developers to people that you really trust, okay? You have to trust somebody sometime. Yes.
Yeah, earlier you were talking about using the NIST-approved post-quantum algorithms. But I think one of the concerns that we're facing right now is that we are possibly dealing with government level adversaries, right? And so.
So why would you trust NIST?
Why would I trust NIST?
Because
Yes.
the algorithms are mathematical and mathematicians can inspect them. It's not the implementation that you're looking for, it's the algorithm.
Yeah, but also dual EC-DRBG was flawed at the algorithmic level, and that wasn't caught until like 10 years after NIST approved it.
What can I say? I mean, it's out there, you can do the best thing, but I can tell you one thing, RSA is dead.
RSA is dead, yes.
Okay, so all of us are still, I love GPG, I started using it when it was 512 bits, then 1024 bits, then 2048 bits, then 4096 bits, but it's dead, Jim.
It is. Basically what I'm asking is why NIST did
Pretty good
not
privacy.
like Brainpool, for example.
I'm sorry, pardon me?
Why NIST did not like Brainpool, which was IETF, for example.
Use whatever you want to, just do something, okay? I really don't care. Just do something, because it's coming. Yes, sir.
So in this year, Motorola announced a partnership with Graphene OS. I'm assuming you're familiar with Graphene OS. Motorola is set to hopefully release a device with Graphene OS in 2027. If you were to adopt this device and follow something that someone in your position would do, a skeptical person who cares enough to go through and verify, what would you consider personally a reasonable level of scrutiny if you were to then try and use this device provided by Motorola but running Graphene OS?
Well, like I said, I'm 75 years old. I'm openly gay. I'm married to a very fine person from Brazil who's going to go for his citizenry on May the 18th. I don't put my credit cards online, okay? I don't do a lot of stuff. I'm not quite as bad as Richard Stallman, but I'm close, okay? And there's a certain amount of trust that you have to put in things, and you also have to trust that other people are going to be using these things and other people are going to be looking at it. Now, I'm not one of those people that says, multiple eyes create goodness, right? Because I worked for a company that was a proprietary closed source company. I knew that there were parts of our operating system that engineers hardly ever looked at or never looked at, okay? Likewise, there's parts of free software that there's only one person working on it, and maybe that person could go completely insane and kill it. So I tell people it isn't how many bugs are in there, because there's always bugs in there. The real question is, when it breaks, how fast can you fix it? It's mean time to fix that's the problem, okay? And it's the architecture of the whole system that's the problem. So you want to have the best firewall you could possibly do in front of you and everything you're trying to protect. You want to use the best VPN you possibly can to protect you on the outside world, okay? And that's all you can do, because there are some really bad people out there who are very happy to go in and grab your data and sell it to a broker who will then mine it for everything they get. And if you think I'm paranoid, well, I am. And the thing is that already, when you use any type of credit card, you've already exposed yourself to huge data mining that's used by the government, that's used by marketing people and stuff. They know everything about you, except how many cats you have. Because I fool them, I put out lots of pictures of other people's cats.
Okay, we can take one more question.
One more question, yes.
Hi. So, I guess one question I have is so a lot of modern machines and devices, they have some kind of initialization code in them, usually some kind of bootstrapping code that initializes the RAM, trains it. because modern RAM needs that, and like, and transfers control to the bootloader. How do you propose that, like, you make that like auditable, or like make sure that like somebody hasn't tampered with it in some way? Besides, you have some mystery meat key run by somebody, which creates its own level of problems. So then you have to trust them.
Well, actually, I'm glad you asked that question, because one of the things that really gets me is the whole industry's reliance on TPM. A chip that nobody really knows how it works.
Yeah.
That's stuck it's stuck in every motherboard.
Yeah, I worked on one in a previous job.
Right. So why not put the functionality of TPM in a hardware key that you can stick into any, port?
Yeah.
And that frees you up from having to depend upon this chip that So this has the circuitry of this chip, of this key on the web. You can look at the circuitry, you can get all the software, source code. And instead of a TPM chip that you really, that limits you to this particular architecture, why not build it into something like this?
So you're proposing something like that for, like, say, like a bootloader, like a low-level bootloader?
Yeah.
Okay, that makes sense.
As a matter of fact, the guy who was the head of the Freedom Box project, I offered to buy him a couple of these keys so he could, work on a hardware key thing. He says, "Oh, wow, I have a headless server that I wanted to completely encrypt the boot file system, but when it crashes and it's going to come back up, how do I type in the password to the headless server?" He says, if I have this key plugged into it, then it can supply the passphrase and the system can come up. I said, yes. Okay, thank you very much, folks. I'll probably be hanging out at the LPI booth. If you want to come and ask a question you didn't have before, you can come and see me there. Thank you.
Is there anything that you can
So I'll just close up here.
Sorry, grinding along
Thank you for coming again this year. We really enjoyed you last year too, and you have a whole different presentation this year, so it's great.
Hi.
Hi. Oh, yes. I see you in life.
Good to meet you.
Good to meet you. I've got the Labrador at the LPI desk, and I'd like to introduce you to Matt Rice.
Yes.
Oh, Jesus.
Hey, Mad Dog. The microphone's still on, whatever.
Oh, yeah, well, it's okay. I don't have anything to hide.
Mad Dog, there was one flaw in your argument. 3 times in your presentation you said, if you were smart, or something like that. And you also mentioned Peter Hegseth.
I understand.
He had all of security, and he had a journalist on the conversation in the middle of an operational exercise.
But even after that, they started saying stuff like, "Oh, yo, it's a secure channel." I mean, they weren't even using an official version.
He's a failure at so many levels. So Neil, are you from Freedom Computers?
Freedom Box. Yeah,
Okay.
Yeah,
Well, actually, they're running on a whole series of different computers. It's just,
I have a Freedom 16 laptop, and is that made by your company? Or okay.
They only really make this, well, the Freedom Box organization only really makes the software. And other companies make the hardware. That they kind of advocate for that.
So, Some of the screening computers is here, I just don't know where. I'll find them.
Can we get a picture of you with our women in tennis from Olympic College?
I'll be happy to, but I'm in the process of closing up
We
here,
don't
so
want to throw
that,
off your schedule.
yes.
Yeah.
And after I get done on the side, we can take all the pictures.
I really appreciate what you're talking about. That Olympic College, we're all, there's a lot of military over there. We are very much into that. What we're doing right now is our project is to teach the students how to do containerized AI.
Yep.
That'd be very interesting if we get through that. Carry anything for you?
No. I have to do everything myself very systematically before I get something.
Can I use just a thumb drive on this? Or do I need my computer up here?
This is my computer.
Yeah, no, I understand that. I'm just wondering if there was...
You'll have to ask her.
Oh, she's the tech person. Great, good.
It's interesting.
I might, if I get one, I'll probably start the new
So FreedomBox is international.
Oh, you have to manually select it.
Some just one and we're not the only bad side is there's a FreedomBox Foundation.
That's like
It's a nice device.
I actually consider the about 40 years later.
And you get services from the box and stuff instead of having to rely on Google, calendar, email, and so on. But yeah, that's mostly for as a community service.
Yeah, we're from over in Bremerton. Kids are
I see, a little bit not.
We're playing with Ed.
Okay.
That
Everything
was quite
is...
a presentation. A lot of it goes over my head. I'm president of the computer club. So my job is to make the meetings happen, to raise the funding, so they're going to come here for getting the Raspberry Pis to run containerized AI and that sort of thing. A lot of this is like drinking water out of a fire hydrant or something like that, so I love it. With you, all this, that all this is,
I suppose the bigger part that we have to take back is the urgency of the problem, especially in the current political climate, to take back the computing into our hands. I think that's the
I'm the same age as he is, I'm 75. So I can think back to all those things he talks about when floppies were 8.5, well, you know, a big one,
Yeah, I want it,
for the floppies.
Oh, I had that with those 504 floppers.
When I was at USC getting my master's degree, I didn't have 500 megabits or 500 kilobits, I had 300 bits of audio. That was it.
Go out and take a picture with the young ladies here.
Okay, Brad, I think he's gonna, we'll follow him out.
Hey man, how you doing? Good. Yeah, I am. Are you at Tech? Oh, good. So what's the easiest way for me to do my laptop, or just use the thumb drive?
Laptop, I think.
Okay.
HDMI.
Okay. Oh, I have USB-C instead of a straight HDMI. Damn, I forgot to bring that.
I think that's good.
You got that?
Yeah.
Great.
No, whatever you have to connect is probably good.
Okay.
What's your name?
Clyde.
Ford. And what's the name of the talk?
Race and technology in the digital age.
Race and technology in the digital age.
Yeah. Okay. Damn, I forgot to do that.
How are you trying to connect?
The only thing I've got on this Surface is USB-C, and it'll go out to an HDMI, but I don't have the USB-C to HDMI connector.
Okay. Interesting.
I do have the presentation on a thumb drive. If there's a computer here, I could just drop it into. And it looks like there is a computer down here. Yeah.
We want to have the recording of your presentation going into the OBS, I think.
Okay, well,
Yeah,
can you help me out at all?
that's what I'm trying to figure out.
Okay. I don't see any USB-C to HDMI connectors.
I guess do whatever you're going to do if you have a workaround solution.
Okay, I don't know that I do, but I'm just gonna try.
I'm trying to get somebody on.
Okay. Does anybody by chance have a USB-C to HDMI connector?
I think I do.
Oh.
It's in the bin. Is there somewhere? Is it? Okay. Yep.
Yep, we got it.
Got
Okay,
it.
we got it.
I got just about every kind of connector.
I got it,
CLI.
but I forgot to bring it. There we go. Let's hope.
If
If that doesn't work, I've got 2 other adapters that might.
Okay.
Your screen on the OBS now.
And is there another port to connect to? This is crazy.
What's this?
Right. Yeah.
I feel like it's not. I feel like it's going to the splitter.
No, I think this is.
Oh,
Yep.
sick.
Yep. We got it.
Wait, Elijah.
We got it.
Elijah, we got it.
We got it. Yeah, we got
that,
it.
But,
Yeah.
but this, so this is going into the splitter. Is that important for audio or something? Like, is this correct?
This is fine. If it doesn't work, then you put it into the splitter.
Okay.
The splitter is only for devices that can't do directly into the computer.
We have audio and video going on there.
So is it possible to get this line off?
That is the closed captioning.
Oh, okay.
So, yeah, not really. It's recording what you're saying.
Gotcha.
So we have audio and video. We're all good.
Yes.
Thanks.
Because they don't always work.
Oh, do you want me behind the desk here so I'm on video?
That might be good.
Because I don't really want to be behind the desk. I'd rather just be, I don't like all the technology in front of me and everybody else. So I'm going to sit here. And do we need to change where the camera is pointing?
Possibly.
Okay. So let's see if we do it this way. Hope that works.
Good. All right. Hey, everybody. This is Clyde Ford, and the talk is Technology and Race at the Dawn of the Digital Age. And,
First of all, thank you for being here. My dad was the first black software engineer in America. He was hired by IBM in 1945, and he went to work in 1946. If I say when I was born, which I will, it'll definitely date me. I was born in 1951, and the first computer I ever programmed was in 1956. So when people talk about being a digital native, I raise my hand. I think I've got some claim to being there a long time ago, at the beginning of a lot of this, and certainly my dad was. My first day going to work for IBM, I went to work for IBM as a teenager, 18 I think, I graduated from college. There was kind of in those days in IBM a bounty on being a second generation IBMer. And by that I mean you were in this special category. So I walked into the New York financial system at the bottom of Wall Street in New York City with the explicit idea that I might be a second generation IBMer, but IBM was not going to control my soul as I had seen it control my dad's soul. So I walked into IBM wearing, for any of you that remember fashion in those days, a blue pinstripe zoot suit with a red turtleneck, a beard, and patent leather shoes with high heels. We'll start there, but before we go on with that, let me just say a couple of things about this presentation, because there's several things I'd like to do with this. I want to tell my dad's story, because I think my dad's story is an important story to tell, not just because he was the first black software engineer in America. In fact, they didn't even call them software engineers in those days. They called them systems engineers. But because in writing this memoir about my dad, I discovered some things that really blew me away about technology that are absolutely relevant today, and I want to talk about those as well too. So, I do want to talk about the history of technology, race, and human rights. I think it's an incredibly important topic. What the implications of that history are, what the current relationship, and my God, the current relationship between technology, race, and human rights and war is happening right now. Right now. You just got to read the newspapers and understand what you're reading, and you realize it's going on right now. And I also think it's important for those of us who are in tech, and I include myself in this because I've been in tech, computer and software tech since the 50s, but as a job since the late 60s and early 70s. So I've been around a long time. I've seen a lot of changes, done a lot of things. Very few programming languages I haven't written in, very few operating systems I haven't worked in. So I think it's important for those of us who are in tech to also be cognizant of some of the issues based on the history, which few of us know. And hopefully I'll have a little time for Q&A. I think the important thing, look, these are my beliefs, and they have nothing to do with the beliefs of Linux Fest Northwest or any of the people involved. I also want to say that there's at least one or two places where the imagery that I'm going to show is pretty graphic, and if it is in any way triggering, just get up, walk out, leave, or talk to somebody after it. You want to talk to me about it afterwards. But I don't want to hold back on what the history of technology is. And that's really, really important for all of us to be aware of. Okay, so that's kind of me. A lot of people, that's the cover of the book. A lot of people say, oh, that's your daddy, he's a really handsome guy. And I kind of laugh, and a lot of times I don't even tell them, no, that's not my dad, that's me. But that's about the time that I first went to work for IBM. So yes, had pork chop sideburns, I had a huge afro, and as I said, if you can imagine a guy with a zoot suit, for those of you that don't know what a zoot suit is, huge wide lapels like you used to see performers in the 1920s wearing. So huge wide lapels. The jacket goes all the way down to like mid thigh, and bright red turtleneck. Oh my God. I gave people some conniptions, as they say, when I walked into that IBM office. And I'll never remember, there was another fellow there, another African American, sitting at the desk, three-piece suit tie, which was IBM dress code in those days. And he came over to my desk and he said, his name was Herb, he said, man, do you know what you're doing? You're at IBM. You can't be dressed like that. Well, I knew exactly what I was doing. And I was making a statement that I wasn't my father's IBMer. So, very, very different from my dad's first day at IBM. My dad was a student, and in those days, and this is very interesting, again, a lot of people don't know, in those days, there was no computer science graduates to hire. It just didn't exist. So IBM had this philosophy, which was very interesting. Let's just hire smart people. We don't care where they come from. And the other place that they often went to was accounting schools. Because with the history of technology, and I'll say a little bit about that as we go on, accounting had a lot to do with computers. There are basically two uses for early computers. One was some type of accounting, and the other was warfare. Early computers were used to compute projectile velocities, projectile parabolas, and if you shoot it here and it's aimed this high, where is it going to land? So unfortunately, that's pretty much a lot of what computers are still being used for today. You only have to look at what's going on in the Middle East, and again, I'll talk a lot more about that. But my dad's first day was based on Thomas J. Watson. Watson's the founder of IBM, president of IBM, actually took 3 companies and squashed them together in the 1920s to make IBM. One was Herman Hollerith's tabulating company, another was a clock-making company, and I forget the third one, but basically 3 companies he put together. He became the president and CEO. He walked into City College in New York and basically said to this woman who was teaching, who's smart, who are the smartest people in your class? She pointed to my dad, and then he said, okay. He didn't approach my dad like that. What happened is the gal who was teaching that class invited my father to dinner at her house. Now, you also have to understand something, that in the 1940s, she was Caucasian. Inviting an African American to dinner was a big thing, not even so much for her as it was for my family. I wasn't alive yet, but my grandma, I've heard the story a number of times, my grandma was like, "Are you sure you want to do that? That may not be safe." And so my dad did go to dinner, and out from a back room steps Thomas J. Watson, president of IBM. And he says to my dad, "You know who I am?" And my dad said, "Yeah." I mean, he introduced myself. He said, "Yeah, you're the president of IBM." He said, "Yeah, and I'm the only person in this company who could offer you a job." And I actually had the card that Watson handed to my dad that dinner. My dad kept that card because it was really important to him for obvious reasons. And so Watson did offer him a job. This was probably late fall 1945. My dad hadn't graduated yet. He graduated that December, and he went to work for IBM in January or early February of 1946. So really kind of an interesting story. Obviously, when my dad showed up to work, I do know what he was wearing. He was wearing his typical IBM uniform. Three-piece suit, tie, kind of a fedora with a raincoat. Kind of different, a little bit different from what I was wearing my first day. Genetics, or not genetics studies, but histories, they punched them in on punch cards. IBM tabulating machines crunched the numbers back in New York, and the eugenics folks felt that that study was successful, really, really successful. They're like, wow, this is really cool. Now, there are a lot of people involved in this, and a lot of really well-known names that were involved in this. Margaret Sanger, for example, really important in women's health, right? Margaret Sanger wrote and said, "Everything I do is in support of eugenics." And I once had kind of dueling op-eds in the Los Angeles Times with one of Margaret Sanger's grandchildren, her grandson, who said, "Oh, my mother was, she was none of that. She wasn't into that." And then eventually it came out, and even the Margaret Sanger Association, Planned Parenthood, actually had to distance themselves from, some of the work that she did because she was so involved in that. The Roosevelts, you name the names in the late 20s that were important. The Roosevelts, the Rockefellers, the Carnegies. Eugenics was the rage of the day, and IBM was the company that supplied the technology that allowed eugenics to move forward. They felt the Jamaica study was successful, so Davenport was proud to propose and implement a worldwide study. And you can just feel Watson salivating. Oh my God, worldwide study using IBM equipment. But now we're talking about 1929, 1930. And something happened, and that study never got to take place because an even larger program with similar goals was happening in Europe, right? You have the rise of Hitler and Nazism. And so there's a principle that we know in technology, right? What do we call it? We call it polymorphism if we're talking about classes, right? Polymorphism essentially means if it works here, the basic idea is going to work every place else, right? That's kind of what you do. You create a class, and then you just use that similar class structure in lots of different instances. That's the basic stuff with object-oriented programming. Well, that idea has been around for a long time with technology. If I have a technology that can help me sort out who belongs and who doesn't, who is and who isn't, if I can't use it here, let me find a place to use it. And Watson found a place to use it in Nazi Germany. When I got to this part of the book, okay, I will just tell you, I went back to the source documentation on this. I woke up in the morning and sometimes I was vomiting. I mean, it's just like, no, I can't believe this, because this is kind of what he was involved with, what IBM was involved in. a couple of things, and I wish I could tell you the whole story. Again, you can read more in my book. I cite a book called IBM the Holocaust, written by Edwin Black, who's since become a good friend of mine. 600 pages of documentation. Edwin's always told me, he said, look, I got 35 file cabinets of documentation. Anybody who wants to dispute me, come and let them try. IBM, first of all, never sold computers. Even when I went to work for the company, they never sold computers. They leased them. Why did they lease them? So they could always retain control of them. So they leased many, many, many computers to Nazi Germany through their agents in Switzerland and France, and sometimes there was one fellow directly in Germany they leased these computers for. And what were those computers for? What did they use them for? All of you I know have seen Holocaust films where prisoners have numbers tattooed on their lower forearms. 9 times out of 10, those numbers are related to a bunch of punch cards that were in every concentration camp. Had this room. It was called an IBM room. And those rooms had, well, it wasn't software, but they had the hardware, the tabulating computers that read those punch cards that were related to that particular prisoner. And folks, I gotta tell you, it was horrible. There were codes in these columns, because that's how the old 80 column cards worked. And those codes would tell the prison camp how that prisoner was going to die. There were codes for gas chambers. There were codes for other forms of extermination. There were codes for this prisoner is going to be used for experimentation. Again, you don't have to take my word for it. You can read about this from other sources, but it was horrible, and IBM was directly behind it. It's not like they just gave their computers, like a lot of people want to say they gave their computers and how you use the technology is up to how you use it. IBM was actually the organization behind creating these codes that Nazi Germany was using in order to proceed with its pogrom against Jews. Now, you can go on the internet right now and find an image of Hitler giving Watson a special medal of the Eagle something or other, for his help in helping Nazi Germany. This is before America enters the war, right? We're talking the early 30s. This is before America enters the war in 1942. Watson goes to Hitler and says, Britain and France, they're kind of bombing some of these places where we've got our computers. So maybe what we should do is build structures that will protect the computers from bombs falling. Okay, and he does that because he wants to protect his investment. When America finally enters the war, Watson goes to Roosevelt and says, maybe we should build bombs that will really be kind of bunker-busting bombs, and then we can bomb the hell out of Nazi Germany. So Watson bombs, and again, don't take my word for it, read it, bombs the very structures that he helped to build. So this guy is getting money on both ends of the spectrum. By the 1940s, IBM punch cards produced in the billions for Nazi Germany. Let me see if I've even got, I think I've got a picture of it. Where do I have it? Let's see. There it is. That is an IBM punch card with the Nazi insignia on it. IBM was producing these, and by the way, IBM created their machines so that only IBM produced punch cards could be read by those machines. So these weren't punch cards that, Hitler said, well, you can get a better discount at Home Depot, let's do it that way. No, these were only purchased through IBM, and IBM printed them for Nazi Germany. By the 1940s, IBM equipment was used not just to schedule and count and maintain what was going on with prisoners in concentration camps, but it was used to schedule Luftwaffe bombing runs. It was used for targeting of what those bombing runs would be about. It was used to schedule the trains that transported the prisoners to the prison camps where they would be executed. It was used throughout the German war machine. In fact, Watson created a special branch of soldiers in the United States Army that used to be known as, quote, the IBM men. And he funded it because he had the money to do that. And when a regiment of US soldiers went into a concentration camp, you would think, oh, well, they're going there to liberate the prisoners. Yeah, 90% of them did, and the 10% who were IBM men ran to the IBM rooms, crated the computers, and shipped them back to New York. It was, in my mind, it was disgusting what IBM was involved with. So now you come to the end of the war. First of all, if not everybody understands computers now, think in 1942, 43, 44, who's understanding computers then? Who even knows what Watson is doing? So at the end of the war, yes, some of the companies who were supporting the Nazi war machine were literally fined. I mean, you can understand Ford may have made trucks and also tanks. That's understandable. But what the hell is a little piece of furniture, like what I showed you? How's that going to help? Well, if you know the technology, you know how it helps. But if you don't, you have no clue. So at the end of the war, there was a reparations committee basically set up that doled out, if companies had investments in Nazi Germany, how much money they would get back, how much money they'd have to pay. Again, make a long story short, Watson was so goddamn slick that his company never paid a dime towards reparations against all they had perpetrated during the war. He did that in a way that we've grown accustomed to politicians doing that. He did that by diverting attention away from what he really did to things that he wanted people to focus on that had nothing to do with what he was really doing. So behind the back, he got millions and millions and millions of dollars out of Nazi Germany without ever paying a dime. Whereas a company like Ford, for example, yeah, they got money out of Nazi Germany, but because they had helped Germans in the construction of tanks, they paid a fair amount in terms of reparations for that. So I was curious to know, how did Watson divert everybody's attention? And again, it's a long story. It actually goes back to before the war and Watson's kind of trickery, basically. Edwin Black, the man who wrote the book IBM and the Holocaust, called me up one day, and he said to me, so Clyde, why do you think your dad was hired? And I said, Edwin, I have a number of thoughts about that, but my basic thought was, Watson hired my dad to divert attention from what he was really doing at the end of the war. And I remember Edwin kind of laughing. He said, God damn right he did. What Watson did is hired my dad, and he hired 4 or 5 Jews to work at IBM. The first black man ever to work at IBM, the first Jews ever to work at IBM. And that people were so like, oh, I can't believe he's doing that they didn't realize, yeah, he's doing that because what's going on the side here is he's just pulling the money that he's made from the war effort out. Okay, sad, horrible story. The war comes to an end. And now, if you think about polymorphism, you say to yourself, well, wait a minute. IBM's a smart guy. I mean, Watson's a smart guy. He did it in eugenics. When eugenics came to an end, he saw that he could do that same thing, that same basic idea, and now pursue it in Nazi Germany. The technology is getting better over time. It's not getting worse, it's getting better. It's now late 1940s or middle to late 1940s. You look around the world and say, okay, if I can't use this technology in Nazi Germany anymore, where can I use it? And this is what I did. This is my thinking. By now, I had kind of gotten sense of the pattern. And I'm thinking, well, where else is Watson going to go with this technology in the late 1940s, early 50s? And then I said, I know where it has to have gone. It's only one place in the world at this time that it could have gone. The idea is, what I want to do is I want to separate out people who belong from people who don't belong. And South Africa is the place you're going to do that. And sure enough, when you look at the history of South Africa, it was IBM involved in the technology behind every aspect of what we know as apartheid. Every aspect. IBM produced and printed, and they actually fought with HP to get this business. It's kind of like Google and Amazon fighting with each other to see who can get the rights to the AI to help support the bombing efforts in the Middle East right now. But back in the late 40s, early 50s, it was IBM who eventually won out and then got the ability to produce the pass cards. So there were basically two types of pass cards. One pass card was you're white, European, don't worry about it. The other type of pass card was often called the Dom pass in Afrikaner by black South Afrikaners, which translates into the dumb pass. And that was the pass card which you had to carry if you were assigned to a Bantustan, which is basically a reservation. So those cards were printed on specially created IBM printers. Now, by the late 50s, you're starting to get into a technology which is no longer just counting. You've got tape storage available. It's got the early versions of disk storage. They were kind of like more like record players than they were really like the disks that we know today. And now you're getting the development of the idea of databases. So the databases for who is considered to be okay and who is not okay in South Africa, created, maintained, supported by IBM. Again, you've got kind of the same bizarre problem in South Africa, if you're a white South Afrikaner, that you've had in Jamaica, right? You've basically got essentially three kinds of people that you want to maintain control over. You've got Europeans who are considered to be the people who belong there. You've got black South Afrikaners whose land you would really like to take and just basically lock them up if you can. And then you've got what South Afrikaners call coloreds, who are basically come from intermarriage between those two groups. And of course, the databases were then used to separate out who was what, just like was attempted in Jamaica, but now you've got better technology to do that. It was really horrible. It was just horrible to read this. Of course, IBM, and at this point, my dad's working for IBM, because this went on straight through the 1980s. I was working for IBM. I didn't know anything about this. You never heard about this. Whoever told you about that? But when you look back at it and you say, oh my God, look at the use of this technology, and I'm supporting this in some way, it was really very upsetting. It didn't stop there. Yes, IBM pulled out of South Africa in 1986, although they actually just sold the business to firms that continued doing what they were doing, but at least they could publicly claim they pulled it out. But they pulled out. But the idea of this, again, the idea is, I want to separate out who belongs and who doesn't so I can subject who doesn't belong to some kind of treatment, whatever that treatment was. You know, in eugenics, the treatment was very severe. They were thinking, well, we don't want them to reproduce, and in some instances, we're just going to kill them, because that way we'll know that we're producing this pure race of people. That basic idea, I'm sorry to say, still continues right to this very day. Who belongs, who doesn't, those who don't belong, well, we've got some fate waiting for them. Separation of families, throw you in a jail, you name it, put you in shackles. There's some sense that whoever doesn't belong, you are deserving of a special treatment. And that process has continued straight through to today. Facial recognition technology really is about identifying who does and who doesn't belong. And it's very interesting. Again, this presentation, I mean, you know, the technology is moving so fast. I think I created this like 6 or 7 years ago, at least this slide, and already it's way beyond what's going on there. So when I created this slide, facial recognition technology was all about how you identify people, and it was very inaccurate. In 2019, there was a study done by the National Institutes of Technology, and it found facial recognition technology is good for one class of people. White males between 40 or over 40, basically. For anyone else, it doesn't work. For women, it's totally inaccurate. For people of color, really inaccurate. For Native Americans, the most inaccurate. It just doesn't work. We can go into some reasons why. I'm sure you know some of the reasons why, because it's based on an AI which requires a large language model, that requires lots of data to feed into it. I mean, there's a lot of reasons for it. But the fact of the matter is the technology didn't work, even though the goal of the technology was exactly the same goal as with the Jamaica project. Find out who belongs and who doesn't. How do we know this? Well, let me just finish this slide and then I'll tell you what happened in New York City. So again, with 2019, 2020, there was, if you remember back then, there was this whole thing about facial recognition technology and some companies actually pulling back from the brink and issuing statements that they weren't going to pursue research in facial recognition technology. And Amazon, Microsoft, and others did pull back in the spring of 2020. That restriction has since been lifted, and there's a lot more work in this technology. ICE is using it now, other places are using it. What I said then is probably right, that these big guys pulling back from it simply open the space for smaller companies to move ahead with it. And that's what we've seen in the intervening years. And so now even the big boys have moved back into facial recognition technology. Some cities, Portland, Oregon, back in those days, I don't know what the current status of this, Cambridge, Massachusetts, for a time Seattle, although Seattle, even under Katie Wilson, has kind of lifted its kind of the guide rails around using facial recognition technology, particularly in license plate readers and license plate cameras, but early on some companies actually prevented using that. Back in 2019, I met with Satya Nadella. I met with the fellow who was the head of IBM at the time, and I sat down and I thanked them for what they were doing in terms of pulling back from facial recognition technology, and said, but you guys got to do more. It's not going to stop with you. It's just not going to stop. And it didn't. One of the things, for example, and he didn't say this, so let me just stay back on this slide. It was not long ago that it was discovered that right after 9/11, IBM began a project, and it had a horrible name. The name of the project was Watson. And IBM began this project in New York City where they used the fact that New York City had a command center, a downtown command center, which monitored some 4,000 in those days, a lot more now, cameras, CCTV cameras around the city. Now, the one thing, again, most people don't realize is that the way you monitor CCTV cameras is not what you see in the movies. When you got 1,000 cameras, there's no human being in the world who can monitor all the action going on. Certainly not follow, you know how you see on the spy show, oh, here he is on this, here she is on this one, oh, she's on this one now. It doesn't happen that way. That's not the way you do it. You have software. You have software that reads, looks for distinguishing features, software monitors it. So IBM started, unknowns to New Yorkers, without their approval or consent, developing the software called Watson that would then be able to identify and discriminate who they were tracking on these CCTV cameras. And in specific, IBM was interested, could they separate out people based on race? Again, I think a horrible, horrible use of this technology, but boy, it did not stop there. Okay, in the Israeli attacks on Gaza, and this is even before, this is shortly after the attack on October 7th. It was basically AI software that was used to target, but also there were several different programs, AI programs that was used. So one was Lfnw. It was an AI targeting program. It was used to identify hundreds of Palestinian human targets a day and, quote, to then target those individuals. Again, early stages of the conflict, sometimes humans weren't even involved really in the decisions. If the targeting software came up with it, that was good enough. Just go ahead and target that person. Lfnw was used, that the purpose was to identify and kill even low-level Palestinians in their homes. Who give a damn about the collateral damage? And here's a quote from an intelligence officer. I think it's really horrible. Okay, but, let me do this, because this was the part of Lfnw's kill algorithm. And again, I'm not going to say by any means that this is just limited to the Israelis, as you'll see in a moment. this was basically the collateral damage that Lfnw was programmed to accept. So these are some of the names of the other AI software that was used in the Middle East, was used early on in the conflict. And the names even just sound horrible. Microsoft was involved in this. Google was involved in this. Amazon Web Services was involved in this. But again, I just want you to contemplate, this is essentially where IBM started. You can draw a direct line between eugenics and this. Okay. This is a quote from somebody in 2024 reporting on this. And again, he's saying, at the end, it's called broad hunting. You copy and paste from the list that the target system produces. You don't copy and paste anymore. The target system just, you'll see in a minute, the targeting system just goes straight through, allocates the resources, dispatches the planes, and you see the results, sadly, on TV and in the news. Now, at Microsoft, there were a number of people who said, no, we can't do this. I can't, in good conscience, be part of a company that does this. And you remember early on in the Israeli-Gaza conflict, there were workers at Microsoft who actually were fired because of their involvement and because of their support for Palestinian rights and against what the company was doing. Similar thing happened at Amazon, right? This is a protest in front of Amazon. Google rather, and Google fired a number of tech workers over this. What I found really interesting, so Google fires the tech workers, who hires them? Microsoft. I mean, it's kind of like this incredible revolving door when you've got this much money on the line. Here's the one at Amazon. So in some ways, I really appreciate what these tech workers are doing, and I think more of us need to recognize that we have a responsibility in this. If we know what the technology is about, if we contribute to actually generating the technology, I think we have a responsibility in speaking up and saying something. Okay, so now I want to talk about, very briefly, Project Maven. And Maven is AI that's used by our country, the United States, in its war on Iran. And you remember there was this report, again, I don't know how many folks know specifically of this project by name, but Project Maven was behind the initial targeting that happened in Iran, where the Department of Defense was just touting, in the first day, we bombed 1,000 targets in Iran. And they bombed 1,000 targets because it was Project Maven which identified those targets, issued the orders that then went straight to the pilots in the planes that were programmed. Their weapons were then programmed for those attacks. And I'll say a little bit more. I'll tell you what that chain is. That chain is called a kill chain, and it's how AI is then used to go from this is the country we're at war with to this is how many bombs we're going to drop. And that 1,000 number is just like basically the United States are just playing with what they can do. But I'll say more in a moment. So just again, Project Maven, it started in 2017 when the United States was concerned that they were going to be eclipsed in this whole movement towards AI's use in war by China. So they developed, they said, well, this can't happen. So we've got to come up with our own project. That project was called Project Maven. Some of the tech workers, I just cited the Google workers who left because of Google's involvement. There were others at Microsoft and Amazon who also left. By 2020, Project Maven was actually authorized for use in combat zones. 2023 now, you get the huge $500 million contract with Palantir Software. Palantir Software got its start not just with Peter Thiel, but with Peter Thiel's father in South Africa, where IBM had actually been involved with Peter Thiel's father in being the technology behind all of the stuff going on in apartheid South Africa. So anytime, I'm sorry, anytime I see Peter Thiel talking about how great Palantir is, I see this direct line between what's going on with some of the worst abuses of human rights right now and what happened with IBM going all the way back to the Jamaica project. Because that's where it started. 2026, U.S. begins its war against Iran, and one of the companies, again, this is current news, this is literally happening just last week. First, Anthropic was in with the Justice Department or with the Defense Department, then it was out with the Defense Department, then Trump threatened to sue Anthropic if they didn't allow the Defense Department to use its AI software, and now it's kind of in with the department again. I mean, this is just craziness, what's going on. So, just again, a quick look at the what's called the kill chain. This is basically how AI is used in order to figure out what's going to be destroyed. So you've got data that's collected, and that data is collected from a number of sources. I just listed 3, but drone, satellite, and human intelligence. Maven AI then, from the data that's collected, does what's called object detection and prioritization. You remember the first day of the war, a girls' school was struck? So the best I've heard from the people who have written about this is the reason the girls' school was struck.
The data was old.
Yeah, exactly. Because with a large language model, you need a lot of good data to support that, and the data was actually a Google map of what that building was, and it had been a military target, but it had since become a girls' school. So the large language model didn't look at Google's map. So 175, mostly young children, were killed. And of course, that's acceptable collateral damage. It's based on this kind of kill chain. So Maven does both the object detection and prioritization. The analysis is supposed to involve human review, but often it does not. In other words, it's straight from what the targeting and the prioritization says right to the strike. The decision, which is basically a go or no decision, go or no-go decision, supposed to involve human review, often it doesn't. And then strike, where actually Maven actually identifies what assets, like the bombs or the missiles, should be used against the targets that it's identified, and then issues the orders for those to be struck. So again, it's not hard to see this line that's happened right from Project Jamaica through to Project Maven in terms of how technology, unregulated technology, is used for some of the worst purposes of human beings. And that, I think, is probably the main conclusion that I would draw. Again, this is not limited to the Middle East. The technology used it is being used on college campuses. It's being used in cities with camera systems. CBP is certainly using it at the border, even touting the fact that they put a cell phone up to an immigrant's face, and that then puts them in the system. Even Starlink, as you look at what's going on right now, right? Starlink's being used on both sides of the Ukraine-Russian war. And so who gets to decide? Well, it's Elon Musk who gets to decide who gets the best coverage. I'm not sure I really like that. Because now you've got a billionaire oligarch basically playing God. Yeah, we'll turn up the coverage here. Oh no, we won't turn up the coverage here, right?
Also ties to South Africa.
Yeah. Oh yeah, obviously, yeah. But, yeah. Okay, so here's what I say before I'll open it up for some questions if we got any time. Do we have any time? Okay, we got some time. A little bit of time. I don't think there is anything in the history of technology to suggest that unregulated technology is going to be used for good. When I finished my book, Think Black, I was sitting on a plane going to a reading in Vermont, and a gal sitting next to me was also an author, and I said, my dad worked for IBM. She asked what I was doing. I said, wow, that's really interesting. My dad worked for IBM too. It turned out both of our fathers worked for IBM at the same time. She said, I got to tell you this story. She said, before my dad passed, he and I were walking down the street in New York City, And he saw all these people doing this. And they were just looking down at their cell phones. And he said to me, what are they doing? And so I explained to him, they're using cell phone technology, and she understood the technology pretty well and how the technology had, what was behind all of this technology. And she said to me, my dad turned to me and said, oh my God, we released a monster. Because her dad, like my dad, were not involved directly in the internet or in cell phone technology, but they were of the group of men and women who were involved in the technology that became the underpinnings for the internet, that became the underpinnings for what we know as cell phone technology. Now in those days, I know because I heard this all the time, oh kid, you're going to love the technology, it's going to make the world more democratic, a lot of people are going to benefit from this, you're going to see all sorts of economic equality across the board because the technology will be used in this wonderful way. A lot of guys and gals in those days really believed that, but it never happened. It never happened. And I think that's a cautionary tale for all of us in technology, that unregulated technology will not be used for the betterment of humankind. The history suggests that it's going to be used for the worst aspects of humankind. In fact, that's probably the case for technology, not just digital, right from the beginning. I mean, catapults and all those other bizarre medieval arms, that was technology that was developed. It wasn't developed for the good of humankind. Yeah, people saw some spin-offs like, moving carts and all sorts of other things that could come from it, but that wasn't the basis of it. In fact, there's a German philosopher, Martin Heidegger, who a lot of people discount because he was somewhat involved with the Nazi war machine. But Heidegger actually, after the war, wrote a number of important pieces, philosophical pieces, on the importance of understanding that technology in and of itself might have within it this sense of not being used for the betterment of humankind, but for the worst. That the very design of technology and the ideas that go into creating technology do not have the best interests of humanity behind them. So yes, we sometimes say, and Heidegger was to say, we're fooling ourselves into saying that it's not the technology, it's how you use it. He was actually saying that maybe it is the technology as well. I love software stuff. I've written bunches of software. My boat's running. I've got more computers on my boat than I have in my house. So, I'm definitely somebody who's not anti-technology, but I also really believe that we need to regulate this technology. I don't believe unregulated technology does anything except create problems. Okay, so I'm going to stop there. We got a couple more minutes left. If you have some questions, I'd be more than happy to facilitate a discussion about it. Yes?
Because they did a study showing that they think that the first casualties in Iraq were based off of cell phone data.
Yeah.
So even when you're turning off your data, even when you're not opting into these things, there are whole agencies that are selling data based off of
Sure.
apps that are trying to do it. So
Sure.
how do we make people passionate about, we've been, even with the whole Alexas and then the Ring cameras at the Super Bowl, we can save your dog. No, they're just trying to make sure they can watch your neighbors,
Sure.
But how do we prove that to people without sounding crazy?
Yeah. So I'm not sure you go out and try to do all that, but you do it in your own life. You do it with your children. You do it with the people that you can make a difference with, and you focus on what you can do. And there's a lot that you can do. If you're working in technology and you understand it, then you can do that. You can even join organizations like Tech for Good. And now you've got a group of people who are working actively to look at how technology can be used for the betterment of humankind. I'm not sure you can convince people. I mean, try to convince people that there's something wrong with the current government. It might be a little tough, but can you do something in your own life that makes a difference, or with the environment? Yes, you can. And I think that's the only thing we have control over, is how we use the technology.
Thank you so much for speaking. I want to see your talk last year, and I'm so glad that you brought it back this year.
Thanks. Thanks. Thank you. Anyone else? Questions? Comments? Yeah, please.
Did you ever find out why your dad was chosen as the first candidate?
I didn't find out why he specifically was chosen. I think it had to do with Watson's relationship with the teacher at New York, no, not New York, City College of New York, the accounting department. I think Watson knew this teacher and had used this teacher to funnel students through. And what happened was this convergence of Watson seeing a black guy who the teacher liked and then saying, oh, that's perfect, that suits my needs well, because I want to get everybody's attention away from what I'm doing in Germany. So I think it was a convergence.
Towards accounting then?
Yeah, my dad was going to be an accountant. Actually, my dad was really, his first love was jazz, and he played jazz trombone, but his mother refused to allow him to be a jazz musician. And so he said, okay, well, I'll be accountant. And it was because he was in accountant school that he was basically in the sights of Watson. Yeah.
Sorry.
Go ahead. Yeah.
And then you mentioned your sister earlier, doing the basket weaving.
Yes.
Where did she end up?
Well, my sister also, had an interesting, wonderful career. She lives in Berlin right now, but she worked in USAID. Not USAID, but aid around the country, around the world. So she worked with Goal out of Ireland. She worked with USAID, and she worked with Pathfinders. She ran refugee camps around the world. And so I'm really very proud of what she did. And yet I don't know that she used the technology, but I do know that we send texts to each other occasionally and laugh because we remember the days of basket weaving with our dad. So. Yeah, thanks.
Yeah, so you mentioned wearing a zoot suit on day one.
Yes.
So how did the rest of your IBM tenure go?
Interesting, because I never caved in, and I saw many other young men come into IBM, and IBM bought them out lock, stock, and barrel. And I'll just tell you one story from the book. I got to a point in my career where I hated what I did, because what I did, I had an office in the Federal Reserve Bank of New York. That's pretty cool. I had a card. I could walk into the Federal Reserve anytime I wanted. I had my own office. And in those days, when a programmer had a problem, they were trying to debug their software, the IBM machines in those days, you basically printed out what's called a core dump. A core dump is everything in memory on folded pages about that wide. It was about this thick. So you'd see these programmers come into my office, and they say, help me. And they got this huge core dump. Now, in school, you could learn to trace pointers. You trace address pointers. You got a red marker, and this points to that, and that points to this. I mean, it was crazy trying to debug a program like that. So I figured out a really good way to do this, but it was very boring after a while. Instead of trying to figure out what's going on, I just asked them, what are you trying to do? Kind of Socratic method. And say, sit down, tell me what you're trying to do. And after about 10, 20 minutes of that, they'd say, oh yeah, I forgot, that's really what and they'd figure out what their problem was, and then they'd thank me. Oh God, thank you so much for solving my problem. And I got this reputation of being a really good debugger. And so everybody now is coming with this core dumps. It was a horrible job. So I stopped working there. I mean, I just pulled myself out of working there. And I went to IBM's data center. IBM had a data center at 53rd and 3rd Avenue in New York, where they had computers that employees used when they were trying to demonstrate stuff for their customers. So I wanted to learn something about, it was kind of like AI in those days. I wanted to learn how to program computers to play games with each other or with me. So I programmed an IBM 1601, one of these pretty nice computers in those days. And I did not realize that everything I was doing was being tracked. So back in my office, the guy who manages accounts calls me in one day and says, do you know that you've already used $20,000 worth of computer time this year? Holy shit. No, not really. So then I walked into my manager's office and my manager's office, and I said, you know what? I don't like the job I'm doing here. It's not using my mind the way I want to be used. And I want to teach at this New York Educational Center, which was the center where I went to use the computers, because I thought that was really interesting. I'd learn a lot. And basically, he threatened me with my dad's job, because in IBM in those days, there was never a posted job list. You could never find out what jobs were available. And if anybody told you about an available job, the person who told you could be fired. And so he basically said, you know, we could fire anybody, because they don't do it, you know, directly. We could fire anybody that may have told you about that job. I said, okay, well, in that case, I'll just quit. He was like, wait, nobody quits IBM. Well, he said, I do. I walked out that day. I went home, and by the time I got home, I had a call from this guy who said, I won't use his name, although I remember it. He said, okay, don't quit. Take a leave of absence. So I took a leave of absence for a year. I taught computer science at Rutgers University. And a year to the day, I got back to IBM, and this guy said, well, that job you were talking about, it's amazing, but it just came open. So I ended my career at IBM teaching virtual machines. Virtual machines are basically the basis for everything that's done today. For everything you know computers do when you don't even think about, we were doing it with virtual machines, experimenting with that early on. So I had this marvelous career, and if you have a unique career in IBM, they don't care about what you wear. They don't even care if you show up. As long as you show up when you're supposed to teach people or be at a customer site. And so I did. I mean, I basically showed up to work 2-3 days a week, and I had a pretty nice job. I enjoyed it. I didn't have to wear three-piece suit and tie only when I was teaching in front of classes. And so, you know, I don't recommend quitting as a way of advancing in your career, but it sure as hell helped me. Yeah, in the back. And then
I'm curious, you know, with ultimately you're aware of the history of all this as well. Like, where are you keeping your eyes on over the next 12 months? Anything in particular, maybe?
Yeah. So here's what I'm keeping my eye on. I think the current AI stuff is like really baby stuff. It is nowhere near what AI could potentially be. And here's the basic thing. AI is used based on building large language models, right? Large language models are based on neural networks. Neural networks is such a antiquated understanding of how the brain works. It's a 1940s, 1950s understanding of the brain as essentially neurons being black boxes. Something comes in, something goes out. That's it. I often tell people who are talking about AI, I say this, look, a child understands how to discriminate faces by 3 months old. You don't feed that child 100 million images of faces for it to do that. So, and I even told this to Satya Nadella down at Microsoft. I said, you guys aren't going in the right direction because you're trying to build it AI based on how much data you feed it. That's not how the human brain works. So I am looking at whoever, and if I was still in the technology, this is where I would be. I'd be very interested in how do you do AI which is based on really an understanding of how the brain works. Neuroscientists do know how the brain works. They do know a lot more about why that child at 3 months is able to discriminate faces. And again, it ain't based on feeding it 100 million images of faces. It has a lot more to do with neuronal plasticity instead of a black box of these neurons. It has a lot more to do with this kind of holographic way the brain works. I'm looking at AI because when AI gets to that point, and it will probably be when quantum computers are used more, not because they're faster.
How they can.
Exactly, because the evidence suggests that our brains work more like quantum computers with all of those bizarre quantum things like, you know, entanglement and all that other stuff. Superposition. So once that began, then I'm really concerned at that point. Because now the AI models are not going to be simulating human intelligence. They are going to be operating like human intelligence. So that's what I'm looking for. Yes, there was a question in the back before you, yeah.
What do you think are the first steps to regulating technology?
Well, okay, I don't know that I know exactly the sequence, but I do know this. You can't get Mark Zuckerberg, who's what, 40 some odd years old, in front of 80-year-old senators, because that ain't going to work, because he's going to talk rings around people. So I think it's going to be that those of us who understand the technology are also going to be the people who have to, in some way, either inform or propose the regulations that need to happen around the technology. So organizations like the Digital Software or the what is it, the Software Frontier Foundation. You know, organizations like that are really important, and I think that's a great place if you're talking about how you make a difference to lend your efforts, because it's organizations who understand the technology that have to talk about how to regulate the technology. Okay? Yes. Oh, 5 minutes. Okay. Yes.
I'm just wondering your dad's experience at
Yes.
IBM. Like, was that a positive experience for him? You know, being the first black guy there?
No, no. I wish I had more to. I wish I could talk a little bit more. I don't think it was positive. Now, he may have said something different, but look, my dad trained the people that then he worked for. Okay, what my dad did, and I appreciate this. This again goes back to this young lady's question about, you know, what do you do to make a difference? Short story. I wish I could say more. Wish I had more time. But in my dad's bureau drawer, at the bottom drawer, like underneath his underwear, he had a bunch of Playboy magazines, right? Of course, as a kid, I knew where they were. But underneath the Playboy magazines, he had a gray IBM envelope that was more risque than the Playboy magazines, because in that folder, that envelope, he had the IBM entrance exams, questions and answers. So what would happen when we were kids, you see, you know, some young African American man or woman come to the house, and my dad said, "Oh yeah, I've invited a friend by," and then you say, "Kids, get out!" Shoo us out of the room, shoo us out of the house, and you know, they'd sit down at the table, they'd be huddling over this gray envelope. Of course, I knew where the gray envelope was, so later on I went to look at it, and then, you know, 3 or 4 months later, he'd say, "You won't believe what just happened. Remember that fellow who was by to have dinner with us the other night? He's working at IBM now, passed the entrance exam with flying colors." So I respect my dad for what he did. I know how much he risked to do that, but he did not have a career that supported him. I didn't either. I wish, again, I had more time to talk about that. You can read about it in the book. Yes, I loved what I was doing towards the end, but it took a lot to get there. So look, I got copies of the book available. I still have a couple of them. And 2021 is really nice. Washington State gave me the Washington State Book Award. I've got like just a few of these hardbacks left. They're $25. The paperbacks are $20. Sorry, I don't have my credit card or anything like that, reader. Hey, thank you guys so much. This has just been really great. Have a really good Linux Fest.
Yeah, you have until noon as well, so.
Oh, I didn't realize I had until noon.
Yeah.
Oh.
So
I have 10 more minutes. Oh my God.
Yes.
Yes, I'll be right over here and I'll sign them as well too. Yeah. So let me just move my computer and I will be at the desk there. Well, you get early release today. 10 minutes earlier. 25 for the paperback and 20 for the 25 for the hardback, 20 for the paperback.
Oh, nice.
This was way different than I thought the term was going to be.
Thank you for being here. So, to whom? A-U-T-M.
Oh, yes, that's not mean, that's a positive thing. But it's,
Oh, yeah, definitely.
That's
absolutely right. Corporations are basically the same as technology. Without regulation, they just do whatever brings them most profit.
yeah, that's what, I work for Red Hat, and we're starting to see that more and more. It's just like, you're like, pays your salary. I'm like, I joined this company back before I did.
I've got, that's more
because of their standards and the things.
Okay.
And now you're saying, well, it pays your salary. That's not
25.
like join
Yeah.
Red.
So that's for the book you just, that I already read.
I have never gotten off of it.
So do you want to know the
As long
hardback?
as my bills are paid, I care more about what I'm gonna learn in the job than people more.
Yeah, well,
lot of
just
hardbacks?
tell people
I've only got 5
to
hardbacks
be
left.
honest, I
Most of
still
the rest are
have
paperback. And I don't want to get, so.
That's true.
Because
Yeah.
I was hired for what
Can
I
I,
was doing
can we do 2
as a hobby,
paperbacks?
and now it's like,
Have one hardback.
I still love doing.
Oh, yeah, you can have 1 hardback and however many paperbacks. So
My
1 more
family in the
hardback.
house,
Oh, no, I'll do the
I
rest.
didn't have to worry about that.
Okay, the rest
I
of
would
it.
still be doing what I was doing, I just wouldn't be working.
She wants a hardback, so can I get
That
one
sounds
hardback
weird.
and one
Okay,
Okay, 1 hardback and 1 paperback. Okay, so $20.
Realm. Okay, cool. I used to make.
And am I autographing this?
I guess,
And
Okay.
then I made your minutes and stuff.
Yes, but I don't have any change
So
right
if I
now.
wasn't doing that, I would be doing that. I would probably be working for Apple.
She was buying it. Okay, so to whom?
Just KL.
Okay, to
What?
KL. We usually don't do last names.
Nothing against the people working at Rocky, but I looked at the leader, Greg's trail of not failed companies that he's burned to the ground.
So much.
And I'm like,
Thank you.
no, I will never
Thanks.
work for you. Just because I'm like,
Thanks.
the Rocky people
Okay, same
I
here.
know
I appreciate it.
are very nice.
Okay.
But
Okay,
I'm
so-
scared to work
Yeah,
for
you can
that
sign it too.
company.
Yes, I will. Okay,
So,
so.
the Rocky people.
Your name?
Alistair.
ALLISTAR?
So I
Oh,
would go
man.
for that one. Actually, do Central Street. Better Fedora and Realm, that's what I
I
wrote.
never would have gotten that. That's beautiful. I like that.
But,
Yeah, I like
anyway, but
unique
if I
names.
wasn't doing my
It's
job,
like
I
password,
would
right?
be
Nobody will,
exactly-
nobody will copy it.
But, yeah, the past years, it's like, a couple of years, it's just like, okay, I've been bonus, and they couldn't make any big changes, there was so many people.
This isn't my
But you just see.
My pleasure.
Ratchet down, and you're just like.
It is, okay.
When you
So-
have to.
Kevin.
It's because of my salary that I got.
Easy
this.
password to break, right?
It's no good password, for sure.
Alrighty, everyone, we have to lock up the rooms during the lunchtime because we don't want any of our equipment running off. So, you got like, I'll do the rest of the rooms first, but
Thank you.
come back.
I was saying.
Thank you.
You're welcome.
Changes, but I know other people are. Now I am.
Thanks, man.
Thank you.
Yeah.
Well, okay.
Thanks.
Yeah, they do.
The Red Hat customer gathering.
Yes, and I've got 3 left. Okay.
That's actually.
And to whom am I making this out?
Asha and Cam.
Asha
That's.
CAM?
Yeah. That's where things started getting ratcheting, and it's just like we're gonna lose lots of
It's
money
double A.
if we don't do this. And we're like,
So, are you presenting on your t-shirts again this year?
I'm doing, so I always did open source shirts. This time I'm doing open source
We haven't had a
patterns,
speaker.
which is not from me, it's from the free sewing, I used to call it free sewing, although it's not free sewing.
Where are you in the school?
Valley College.
Okay.
We're in this cybersecurity program.
Well,
They accepted my thing, and then I went to.
Yes,
Yeah, we should.
we should.
And the guy
We
who
always
does
listen
that
for
gave a talk to
speakers.
him. He had an hour and a half, an hour and a half, so it's.
We'd
Give
love
us a
to.
sense of what it is.
But anyway, it'll be open source patterns.
Thank you.
Have a good festival.
Yeah, I just want to check your hand.
Hey, man.
Yeah, I'm on my way here.
Well,
That's why I'm like.
yeah, I've been excited about it all week.
Oh, good. Now, where are you in school?
I'm at Bates
Even if you
Technical
haven't
College.
And where is that?
I actually don't see what I don't.
Okay. And what are you studying?
Computer information and project management.
Okay.
It's a new program.
I'll put stuff on there.
You know, I'm older, I'm switching careers, but my first bachelor's was sociology. So, like, the route you went down was just like, right down my alley. It's crazy, getting a bachelor's, we didn't really talk about the technological component of, it's just like justice. It's more just like, black kids don't have access to computers, things like that. But I'm like, man, they should be teaching us this too, But, yeah, I appreciate it, man.
Good. Thanks for being here.
Yep, take care.
Yep.
Thank you.
You're welcome. Take care. Hello.
Didn't have my cash with me.
Oh, okay.
But I also wanna say thanks for your talk. I really appreciate it.
You're welcome.
And you're sharing all of this with us.
Good.
So yeah.
Good. And your name?
My name is Marietta.
Marietta.
Yeah.
Pretty name.
Yeah, thank you. Yeah. Yeah, if you have time, I just want to express, like, I've also been learning about my own, history.
Yes,
Like in
yes.
Indonesia. Like
Yes.
the long history of like oppression,
Yes.
especially to the women of Indonesia. So when I hear about this, that you're also sharing the history about, about Watson and all of this, I just feel personally like connected to it.
Yes.
Just-
No. Thank you for saying that.
Yeah.
I appreciate it.
Yeah. I need to grab my cash.
Yes. So, do you want a hardback or a paperback?
Let me
25
see.
and 20.
I'm not good with this one. Yeah.
Okay. And let me autograph it for you.
Thank you.
To whom?
Marietta.
M-A-R-I-E-T-T-A?
Mariatta.
A-T-T-A.
Thank you, sir. Thank you. Do you mind if I take a selfie?
Oh. But let's do it in the hall because I think they're trying to lock these rooms.
Oh, okay.
And I know
Yeah,
the
yeah.
guy said he was gonna come by and do it.
Oh, I
so
see.
Let me just get all this stuff out of Darren.
Okay,
Hopefully
yeah.
we can do it in the hall. Yeah, we'll just, yeah, if you can carry that, we'll just step right out here. That black wall is probably good to take it.
Not a lot of room for the mix. Maybe right there. Okay, then we'll have to go back. Excellent, everyone's already out. Can you see that one? Not right now. Yep, everyone's out.
nice having somebody to introduce us and take care of the room in case something goes crazy. Thank you.
Yeah, no problem. That's something that we found is really important.
Yeah, I put on quite a few events. It makes a world of difference. Thank you.
I'll pass the word along as well.
Flavor is it red?
There is a microphone right over there at the corner.
Oh, okay.
Yeah.
Do you have to pick up or you just talk?
You just talk. It's able to pick up your voice as long as you're not like really far from it.
Okay, awesome. Do you need to do anything to switch over the screen?
Unfortunately, I was told to not, that like, even if you know to not touch this kind of stuff. Let me see if.
I was like, I'll wait to see if you folks put in there, so.
Okay. So anyways, are you to handle switching over?
Here to help. More space.
Okay, here to talk about security in the open source is Autumn Nash.
I'm just switching over displays really quick.
Okay.
Hi, I'm Autumn Nash, and I'm here to rant about security. So today I'm going to be talking about the shared responsibility model between open source and how we all consume and use open source. Oh, Has anybody ever played the game Hot Potato when you were little?
I have an electric version of too.
What? They make
It
those?
shocks you. Yeah. It's great.
Imagine that to my kid's Christmas list. Okay. Okay, but that's what we all kind of do with security, right? Like, it's always something that nobody wants to deal with or be responsible for until it's too late, right? So people are like, hot potato, it's not your problem. Let's let DevOps or the security team or somebody else deal with it, but we don't want to deal with it. And that happens even more so when it comes to open source, because who's really responsible for it? Is it the code? Is it the build pipeline? Is it the artifacts? Who's going to do all these things? Because open source is really just a big community of people contributing and building software. And there isn't really a spoken for sure contract about like who's securing all these things and what everybody's job is in this. I'm Autumn. Those are my cute kids. Those are my two best friends that are in the back. I started off as a solutions architect at AWS, so I don't know if anybody's heard of the cloud shared responsibility model, but that's what I started out explaining to customers, which kind of inspired this talk. And then when I was a solutions architect, I worked on databases, and I worked with the open source community of Cassandra that also corresponded with Keyspaces, which was the database I worked on. So I started off like in open source from the beginning of my career, and then transitioned to being an engineer on OpenJDK, and now I build Linux. So I've been in open source my entire career. So today we have more tools than ever to build software, to secure software, to find CVEs, but at the speed in which we're contributing code, their software maintainers are absolutely just being flooded with new code and all these people trying to contribute. But we also have to secure this code. I don't know if anybody knows, but most people that work in open source, they're working for free. Those contributions are free, and people are spending their own time to do that work. But 70% of infrastructure that's running in production right now is built off of open source. So majority of the things that we use every day, you're just trusting somebody that you've never met to secure and to do all the right things. And they're not getting paid, so they probably have a day job and a life on top of doing all that. And along with more security tools, we also now have more tools in which we can do unsecure things, right? So like now we have the same models putting the same insecure code and making the same mistakes over and over and over again. We are producing so much code that we don't know if, like, some people are not doing the best job at making sure the code that they are contributing is secure. A lot of people don't have the context about what they're creating to know how to secure it, right? When you have 3 agents working at once. I don't know if anyone saw, but a quantum computer just broke the encryption or whatever security for Bitcoin the other day, and it did it at a 500 time, like, it was able to do it 500 times faster than it had broken the record the year before. We're talking about a year. We're not talking about 10 years. We're not talking about anything crazy. Anthropic's new model is said to have found a 28-year-old CVE and found thousands of day zero CVEs that they said, that they are so scared to release it because of what it could do. So if you can find those CVEs, you can also break new levels of encryption. So the possibilities are endless. And we can't secure something that we don't understand. So this is a shared responsibility model for cloud. I'm sure many people have seen this. And it really breaks down, well, cloud companies create this for a reason, right? They want you to understand what you own as a customer versus what they own. Because they want, for one, when you come back to them complaining that something's insecure or not working or it was breached, they're gonna tell you that was your job, right? And it's really important when we have so many pieces to the software lifecycle when we're building an open source. So this is actually from a vendor that will not be mentioned website to explain how their day zero images and their like shared responsibility model. So like, let's think about this in context. They're saying that all of their different images and languages will come from upstream. They're saying that upstream is responsible for all that code. They have no idea what's in that code. They're not in any embargo like channels. They have no idea. Upstream is responsible for it.
Is it okay to close the store?
Yeah, sure. Thank you so much. They're saying that they are in charge of the build process, which is great because that is important in the supply chain attack, right? And then you're responsible for everything afterwards. Can you imagine this is your whole business model and you're like, I am in control, like I am not responsible for like majority. So like it's all on you, right? So like I think right now we're in a time where everybody is claiming that they're your solution to security, right? Everybody is like 0 days that you know about, right? Like how do you know if you're not a part of those open source packages and the different projects? So now you've got like, we have so many areas to look because this new cycle has evolved, right? We've got new software licenses every day that people are open sourcing and then closed sourcing and changing their mind. Understanding this process and understanding open source is going to get more important than ever. So you have open source, then you have like a vendor or distro. I don't know if many people know, but companies like Microsoft, Amazon, Google, they have a lot of their own like sources for like Java. Like Amazon has their own Java that I used to work on called Credo, right? So they contribute upstream to OpenJDK, but they also build and maintain and patch their own version of it, right? And it's cool because they do it for free, but it's really, the optimization and getting those security patches early are so worth it for these big companies that they are spending the money to maintain those teams. But it's really important to learn, to understand what these distros do, right? So whether it be a Linux distro or a Java distro, they're kind of different processes, right? So when you have OpenJDK, you have this big umbrella and it's very specific on what you need to build Java, right? Like you have to have certain tests to build Java. You, for the most part, have most of the same packages, right? When you're building a Linux distro, Linux is like your own religion, right? Like people have different packages. They might want a very small, secure image that only has the bare minimum, or they want something that's easy for beginners and they put like everything in the kitchen sink in it, right? So for someone to really come in and try to understand what you're getting, if you don't even understand the recipe for something, you can't make it, right? And then how are you going to make sure that it's secure if you don't understand all the things that are going into it? So I think it's really important to understand that you've got open source, which is making your code, right? It's making the code that millions of people or thousands of people, however many people, are contributing to, right? People are working together in different project teams. So like, for instance, with OpenJDK, they have different like garbage collectors or just different parts that they've worked on to move that forward. And sometimes it's optimization, sometimes it's like a new special feature. But for Linux, each package, or not each package, but many packages have their own maintainers completely that are agnostic of a distro, right? So think about the coordination that it takes when these people have like their own maintainers and they don't necessarily work for any of these big companies, but they control what goes into those packages. They control the embargo lists, and a lot of these embargo lists will only have a few people on them, right? Because you don't want the world to know what you need to be, like, what is vulnerable. So let's go back a little bit. What is an embargo list? So an embargo list is usually like a list of a few people that work for a project. And these people are like a security expert, or they work or they're interested in security. And when people find vulnerabilities or bugs and they get reported, if you go through the triage and you figure out, like, is this truly a security risk? So there ends up being like a mailing list of people that you, like, for one, will go and verify that that is a security bug. And then they kind of work around getting a fix out. But nobody ends up having this information if you're outside of this list. So truly, nobody knows if any of these open source projects have a CVE unless it's publicly found and reported. Majority of them, they're going to go to an embargo list and get patched, and then they'll come out with the next release, right? So when people claim to have 0-day images, it's 0 day of what they know, because unless they're on embargo lists for all these different distros and packages, they won't know what that is. So your code is one thing, and then when you become a vendor or a distro is another layer of responsibility. How it's being built. Are you putting in some extra stuff with the code? Just like the Trojan horse that ended up coming in, that one malicious attack that the person had done social engineering to get the maintainer to allow them to be another maintainer. And they ended up adding in extra artifacts. I think my computer keeps going to sleep. So securing the code is one thing. Having a secure pipeline and building secure artifacts is something else, because you're not consuming the code. Most of the time you're consuming the artifacts, right? So if you think that you're consuming one version, but really the next version, or let's say somebody socially engineered and they released on Twitter, hey, this version of Linux is bad, bump the new version, and the new version is a malicious version and malicious artifacts, right? Like, we live in a world where social media and buzz, you can easily create kind of like risk and people wanting to react quickly to be safe, and it could be something that is the opposite, right? You confuse them and then you insert risk. So open source is going to write the code, they're going to fix the vulnerabilities, they're going to coordinate disclosure, and then they fix it through embargo and through their release processes. But it's not going to deploy it to your system. Sometimes it's signed, sometimes it's not. And it's not going to patch your environment, and it can't force you to take their changes or to be aware of a situation, right? Distros do, for the most part, sign. If you get something from Amazon or Microsoft, it's going to be signed, and it's going to say, this is from this big company. They have done a lot in open source to try to make it better, where we have more like signing and security, but again, this is like a coordinated process, right? And it also takes money. So if you are well-funded like the Linux Foundation, it's much different than being a smaller open source project that doesn't have the same funding and doesn't have the same power behind it. If you're an open source project that has a lot of big companies contributing people to it and contributing money, you have much more resources than a smaller open source project. And a lot of times with something that's like a Linux distro, you might have this new package that's really cool and really useful, but it only has a few maintainers. That added stress on those maintainers can already be an extra way to introduce risk to something, right? So a distro is a really good way, like, to verify that it's being built in a certain way. You know, if it's a bigger company, they have more infrastructure, they have an ability to sign build-in controlled environments. A lot of times, they even offer smaller images that will be stripped down and will only have packages that you need, so you know that you're not getting a bunch of extra things and pulling in dependencies you don't need. A lot of times they'll have SBOMs, and an SBOM is kind of like an ingredient list, which is great. But it's really important that I can give you a list of a sandwich, and I can tell you there's peanut butter, there's jelly, there's bread, but it doesn't say, by the way, it's not poisoned, right? Like, you could still have all those things and it be poisoned. So an SBOM is not going to like completely protect you from everything. A lot of times they can also have curated and selected packages. So like, if you are getting a something that you're getting an image that you want to run in the cloud, it'll have cloud, I won't say agnostic, but cloud specific file packages already downloaded. So if you're on Azure and it's from Microsoft, you're more likely to get things that work better with Azure and optimizations. And with AWS, they have their own Linux that works better with Amazon. Also, those distros are going to have applied packages that are often backported from open source, and sometimes they'll have their own, depending. But they still don't have insight to embargo unless they're a company that very much has a relationship with open source and that actually has and maintains maintainers. So they're allowing their employees to get paid by that company but work on open source projects. But again, they're not controlling how you build things, they're not controlling how you patch or how you update things. That's your responsibility. So when there's a lot of moving parts, it's kind of where it goes wrong, right? You can't really secure something that you don't understand. You can't secure something that you don't understand the process. When we make food, we have laws and regulations on how you can produce food that's safe for other people. We have inspections. We have a lot that goes into that process because we know that it's important. A supply chain risk is also very important. When 70% of infrastructure is being consumed from open source, but we don't really have any for sure, we don't really have a contract, right, between these vendors, open source project and companies and just regular customers consuming it. It's kind of just each project has its own rules. Each company decides how they want to contribute to different projects, right? Depends on how much it works for them or how valuable they deem it to be. A lot of times people will be like, well, we thought upstream fixed it. We thought distro patched it. I thought that I took out that extra patch that I added into something, you know? So it's like, it's really easy for you to miss something if you don't understand how something was made or if you don't have enough insight into it. When you pull in one package, how many dependencies does that pull in, right? Like, how many times have we seen it where the package was fine, the code was fine, but the dependencies are like poisoned? You can also have poisoned artifacts, but it's really important to understand, for one, what it's made out of, what are your risks, right? Like, there's always a risk, there's always a trade-off when building software, but really fully understanding that, I feel like it doesn't matter if you're using AI, it doesn't matter what you're building. If you don't have the proper context when you're building something, how do you know that you're building it for the edge cases and it's secure? So everybody loves open source until it's time to fund it, to volunteer, to contribute. I think it's really important that we get to the point where we're good stewards of open source, and I preach this all the time. I like every talk I can fit it into. We are benefiting in the things that you use. Like, Linux runs the cloud, right? Like, the cloud is basically a bunch of Linux servers in somebody's warehouse. There's so many services that in just the world runs on Linux, and many open source projects. So a lot of what we use every day is running on somebody's volunteered time out of the goodness of their hearts, you know? Everybody has families, we all have day jobs. Sometimes we're lucky enough to have day jobs that pay you to work in open source, but it's got to get to the point where companies are getting into open source and doing the work before they want something, you know, before they're just going to take a profit from something. Also, I think open source is a great way to find community and to start a career or even just transition your career. If you really like something and you're using a product, even if it's just on your home lab, think about contributing. Like, even if you contribute to documentation, say you're installing something and a bunch of the instructions aren't correct. If you update that and say, hey, I found this, you forgot a few of these commands. A lot of times when you're building something and you go to write documentation, you forget parts that you don't know because you've been looking at it for forever, right? So the smallest documentation and the smallest fixes are actually really important. You can also encourage your company or team to help fund and contribute to open source. There's a lot of give and different fundraising things that we do at work. And I think that it's a really good opportunity to say, like, hey, I want to volunteer some of my time on this project because I really enjoy it. Reporting bugs and security issues are also a really good way that you can help people. Also, make sure you give your logs. Like, everybody loves it when people point out an issue, but please give us enough information to help you, because it really helps. I think also, like, be nice to the maintainers, please. I know that we all want things and we would love to have this patch faster, this new thing that another distro is using, but typically these people are being absolutely hammered by this. Like, if you have a problem, 5 other people have found it. Not that we don't want you to report it, but just be kind. It might take a little bit longer to fix, but they're working usually and not being paid for it. And even if you're being paid for it, you're splitting your time, right? Companies want to make money. So you're generally, people are splitting their times between many other projects and contributing to open source. Respect the embargo process. I know sometimes it's cool to, like, post on social media or whatever when you find something and you want to tell. And I'm not saying you can't do that, but a lot of times, if the more we talk about vulnerabilities, like, as much as we want to find security vulnerabilities, it's also letting malicious attackers know that the vulnerability exists. So just be careful. But yeah, sometimes donating $10 could be really cool. Or if you have, like, I don't know about other people, but sometimes your company will have, like, hey, you can give $50 and we'll match it, or a certain amount. You can contribute to nonprofits, or maybe you contribute to something that, you know, open source. If you're a leader, you can also really work with your team to define clear ownership boundaries. I think ownership is really important, especially now that we get in farther into, like, AI, into just kind of speeding up workflows. I think it's really easy to be like, not my job, right? But it's all of our jobs. And that's actually my favorite thing about security, because that's one of the times where you see a lot of different vendors and companies work together because they all want to solve that problem. So I think it becomes like a communities issue when you see security issues. So I think kind of like really bringing in community, but also just having clear ownership boundaries and forcing people to take care of things, but also incentivizing taking care of it. And when you find something, upstream it. At least let people know, and maybe if you fix it in your workload or in whatever you're doing, why not at least give them the option to take your patch or to take your fix, because you've already done it, you've already worked on it, right? Funding and maintaining upgrades. If you are the leader of a team and you can make those decisions, it really helps. And just incentivizing patching. So actually taking the time to like put some time on your team's calendar to like go and patch and upgrade and to make sure that we're taking care of that technical debt and security debt, and being intentional about it is really important. Any questions? For the most part, it. Oh.
I think we're.
Okay. Oh, if anybody wants to connect with me on, I didn't get my link on there.
Question over there.
Oh, you got a question.
Hand up.
I think sometimes we need, I don't like this, but I think sometimes we need to be able to secure things we do not understand. to go to extremes, I mean, this happens every day.
Yeah.
But to go to extremes, as we generate more and more code through AI, God knows what's in that code. And we're going to be using that for serious things. And I think we're going to have to, I mean, I don't know, we're going to have to rely on black box testing or something.
I think that's a part of the testing, but I think that whether you make it with AI or not, if you're the developer, you're still responsible to go through and look and try to understand what it's doing. Like, I use Copilot every day, but it's on me to figure out like how it's built, and like it's a help, it's a tool, but it's not like if I'm there for a reason, I still get paid for that job, right? Like, so I think like we do have to have an overall, like, I think there's always room for guardrails, and there's room for really incentivizing and keeping those rules of like, hey, this is how we're going to overall test. We're going to do chaos testing. We're going to test, like, we're going to do automatic testing that we do like nightlies or whatever your way of testing is. But I think it also is the fact of like, even if AI writes you 4,000 lines of code, you still need to figure out what the code does to some extent, or even find ways to use that AI to maybe do some of your testing or to write tests for you. But I do think that, like, I think that's the danger. We can't get to the point where we're just like, not our job, like whether, no matter which way it is, you know.
No, I agree, but I do think it's a problem we face.
Oh, yeah.
Actually, we have in the past. I've been in charge at times. The wonderful thing about open source is you can actually look at the code.
Yep.
I've had a job or a task in the distant past where I had to test proprietary code that I legally didn't have authorization to look at. And yeah. I just say it's a problem we face.
Oh yeah, it is. And I think that it's just like, I've been in a situation like that where they're like, we need you to like make sure this is secure, but we're not gonna let you see it. And I'm like, what do you want me to do? I mean, I can do a few things, like I can see if I can get into it, but like I think also like sometimes telling people no is really good. And being like, hey, like I get it, you want me to do this, but I'm just like, this is the extent that I can make you happy, and this is what I can do for you, but I'm not gonna, like, you know what I mean? Just being like brutally honest, that doesn't always get you fans, but like, yeah. Because I've definitely been there, and I'm just like, I don't know what you want me to do for you, but yeah. Like, I think that it's not even just that, like, so I really do love, like, I don't know if anyone's ever heard of it, but they have scorecards now. And I mean, that's still open source, but the Linux Foundation has been working on, like, scorecards where you can, like, you add the scorecards to your distro, I mean, not distro, but to your GitHub repo. And it will tell people, like, how secure your project is. And it's very hard to go from, like, 80 to 100. But for the most part, you can get pretty well, like, started, you know? But that's something that the Linux Foundation has been pushing a lot, and I think it's a really cool way, because when you, like you said, we don't always have insight into everything, and while open source is open, maybe, like, we don't go through every line of code in an open source project before we use it, right? But I think scorecards is a really cool way to be like, hey, we take security seriously, and this is what we're doing. And it's kind of like something that you can look over and kind of understand and know that they're at least taking some precautions and that they care about security. So I think kind of signaling those things in a way also helps, because you want people to trust your software and to use it, right? So I think coming up with those different tools to signal to other people, and then to kind of like how like what you said, the one thing that's good about open source is that people can see the code. So maybe if people are going through your code, you're hoping that they like give you feedback and tell you when something's wrong, you know? So I think it's kind of like a situation where you have to have like a holistic healing to it, you know? There's so many different aspects, and honestly, like, watch the news every day, like, it just gets harder and harder. So I think it's gonna be like, it's just a moving target at this point where we're gonna have to continue to make good solutions to the problem. What do you have? Okay.
I have a little comment, but I was just trying to think how to ask the question, or just throw it out there. So So it seems that we may be sort of like resetting us security again. So what happened way back in the day, even when Gates and Paul Allen were writing BASIC, they were doing that on a PDP-11, PDP-10. In those days, the hardware manufacturer and the software manufacturer were working very tightly together. Mm-hmm. And there weren't all these, it wasn't, a lot of those systems weren't networked. They were in a military context, for example, for the nuclear launch systems and command and control. So there was a lot of security there. And then it split when the PC era came around. Windows split from x86 and they diverged, and there was again no real concern about security until they were networked again. And then you got the social effects, people hacking into the systems and doing things that they shouldn't or they should. Now it seems that it's coming back together again. You've got people like the iPhone. They're so miniaturized that they've got control of the code and the hardware. Now in the Linux world, it seems like the hardware's still out in the wild, but the code's under security control. So I guess my question is, should we be incorporating the hardware into our security arena?
I've actually seen a lot of conversations where people are doing a lot of communications with chip companies while building new distros and talking more with people with hardware. I also have heard of a lot of really interesting conversations about putting sort of guidelines and just different gates into hardware to help things stay more secure, which I think is a really interesting premise. I do think that it's going to get to the point where there's this is such an evolution, teaching security to humans is really hard, right? There's so much social engineering and extra, it's not just the technical part, and now we're being able to do the technical part and the writing of code and the changing so much quicker, and we can't even tell people to use the to do least privileges for their team. Now it's for your agent, and for so many other things. Didn't Anthropic's AI just completely escape out of a room with no internet the other day, and they're it's too dangerous to give out. One of the agents was saying that it was coming back to the user and saying hey, I did such a good job, I found a workaround when you told me not to use this file. You know what I mean? It's almost amazing that we're solving so many problems and creating them as we go, so it's both exciting but very you're right, it's almost a full reset because we're fighting the same problems but then at a different scale and then creating new problems, so it's interesting.
And I think on the hardware note too is especially Linux, there's so many generics that even if they theoretically put support in for security controls, it's oftentimes disabled, or because Linux is used so generically that they can't do comprehensive solutions because it breaks too much stuff. One of those things with hardware is the I forget the exact term, it's the indirect branch targeting stuff they put into at compile time, where they'll put instructions in the code at the beginning and the end of functions to prevent indirect branch attacks. Because Linux has to stay so generic, they have their solution is just kind of half-baked, so it maintains compatibility. So I think that kind of what you're getting at, maybe I think, is having tighter hardware integration with our software to actually build comprehensive solutions versus ones that are it might work on your PC, might work on your PC, whatever.
That's a big issue with languages too, because if you think about it, Java has to run on multiple architectures, right? So it's making, I remember when we would do testing before it got completely automated, we were literally pulling up laptops to try to test those new builds on each laptop, So it's I think that and it's also interesting because we're also talking about optimization, right? To run these huge AI workloads, we need chips to do more with less, right? So we're constantly in this battle of optimization that I think chips are going to play a really interesting part in a lot of the hardware, and I think it would be really interesting to see where that's going to meld,
One question for you unrelated to the talk. You said you worked with Cassandra a lot. What was your Cassandra experience?
I worked with people that were already having Cassandra-like workflows, and they were trying to see if they could use a managed version of Cassandra. But it was cool because it was managed, but also still like open source. Like they weren't open sourcing it, but it was like still the same access patterns and a lot of the same learnings as you would do with Cassandra, but just a managed version. And I got to learn a lot about the different trade-offs and everything, and it was my first experience to like an open source community and getting to talk with them and getting to see all these people building and like contributing and seeing how two big companies were kind of like competing in this open source arena. So I think it's really interesting. Like there's so many politics that go with open source, but there's also like a lot of people that just honestly love what they're doing. And then there's just finding the company that will pay you to do it. So it's just really cool that like you'll go and there are these two different companies, but they're all friends and they're all still like kind of contributing, even though there's stuff they can't tell each other, you know? Like I think the whole world of like open source is just an interesting development. Also, you get to work with people from all over the world. Like it's so rad. Like you're talking to somebody and helping patch something in security in like Germany while you're in America, and then somebody else is on the like phone from like, I don't know, Brazil. You know what I mean? Like it's such a cool way to meet people, but it's also like there's a lot of stuff in tech that maybe doesn't make you feel good when you have to contribute to it, and then when you see these things that are very simple, like a database or like Linux that isn't doing anything bad, and that you're all working together and it runs like in everything, you know what I mean? Like Java runs Minecraft. My kid thought it was so cool when we could use Corretto to run Minecraft, you know? Like, or I can't wait to run Bazite on my like Legion Go. Like it's getting back to the tinkering part, you know, and the community part, and it kind of makes you feel like, to me, like the spark a little bit more, you know, and like what we all wish tech was, and not just like AI doing all the fun stuff. So to me, like I'm super grateful that that was my like way into tech, and that I've got to stay into that arena. And every time I get like verged off, I try to find my way back to some open source community, because I feel like the people will keep you excited, you know, and the like being able to contribute and all work for like the same goal. I feel like that's a human need, you know, to feel like you have like a purpose. And I think that open source fills so many, just like when, like I remember being at GitHub Universe when the layoffs got really bad and people were getting laid off at GitHub Universe while they're speaking, and there's some of the like giants in their field, and people were like, I'll refer you to here. And like, you know, just like it's the community and the good that reminds you that there's still good there. So I'm super grateful to like get to be in those communities, and I think I highly recommend, if you can get into open source somewhere, just be willing to do the work. Like I will write documentation, I will fix a small change, but being a part of that community is really worth it to me. So.
There's a fair amount of push to go for security through exclusion now with things like the upcoming Android lockdown and other things. How do you argue against that when people are able to make solid cases for that actually improving security?
I think that it depends, right? Like that's the famous line, but I feel like anytime you make something not usable, it's just people's way of being that they will then go around your security, right? So I think that it's the constant battle of all time of working with usability and security, and also like education of like why you made those changes, so people like want to like adhere to them or accept them. So I think a lot of it is trying to get it right, and sometimes we just don't get it right, like honestly. But I think if you get the buy-in from like your users, like defaults are always important, right? Like you need to have those defaults because some people don't care, and some people are just gonna go off the defaults and never touch them. But I think it is important to like make sure you're balancing the two, and then educating people at what they may not like. So. But it's not really a clear answer, but it does depend, you know.
Thank you very much.
Thank you. Thank you for your awesome questions. Are we next in this room? Sweet.
The previous years I've come here, never had rooms that fill with their stuff. The new one.
Adam, do you remember last year when you were doing a compliance test for, at first I thought it was you.
I had to talk about why.
What's that?
I had to talk about it.
Or at least for the.
And then we made contact with a lady out in Canada who is working on a major bias testing program. So anyway, I just thought, now, do you work at, where is it you work? Yeah, and see, our AI ambassador, we call him, he works at Microsoft. And so I'm just the president. He's the one who really, I get the money, and then he spends it to put together an AI network with Raspberry Pis and another network with all containerized so that some students can go in the workforce, not throw all their data on the cloud to be hacked into. We're risk really conscious over there. And I was wondering, are you involved in anything, a program that I might pass on to James Duffy? Maybe something that you're doing up there at Microsoft in the area of AI or bias. He's interested a lot in AI, hosting AI in a containerized environment.
I give a lot of talks about different biases and stuff, and I
Do
give
you
some
really?
resources.
He would be very interested. Do you have a mail list that we could put him on? I give you his
You want me to give
email
him my
address.
link?
What's that?
Want to just give him my link? Or even my
Yeah, that would be great. Or if you want to just, I'm very old school. So if you want to just write it, otherwise you could send it, whatever's easiest for you. Here's my name and my something from him, you'll know that it's from James Duffy, and he might send it from his student email, but he's
Was he
on
here
campus.
last year?
Yes, and and I think he's.
I think I met him. Was he at Microsoft campus for a little bit?
Well, he's working there right now. That's why he's not here. He had to stay on campus until 5 o'clock when our bus had to leave before we could have him come.
What is he doing?
They'd have to shoot him if he told me. I don't know what. He said, I'm going to go over there and see him.
Okay.
But when he and I are together, we're always talking about AI and the OC Computer Club and how we can get the money so students can get the experience. But those are the names that you'll be watching for, and I'll give him this information. Thank you so much, Autumn.
Find me on LinkedIn too, that works too.
What's that?
And I'm on LinkedIn too, if that works.
Oh, okay. And what is your LinkedIn?
You can just look up Autumn Nash.
Yeah, so just Autumn Nash.
Yeah.
Yeah, LinkedIn.
There's a really awesome Dr. Catherine Hicks, and she does a lot of human psychology and the way the brain works and software development.
Oh, really?
And she's
What's
got
her name?
Catherine Hicks.
Oh, Catherine Hicks.
And she does a lot of really interesting work with all of that.
Is she on the internet? I'm not sure.
Yeah, she's on LinkedIn and Blue Sky, and she has a website also.
And does she work at Microsoft too, or she?
No, I think she had her own lab for a while. I don't know where she's working.
But anyways, Catherine
Yeah,
Hicks.
but she's
Thank
a
you.
research scientist.
Right around here, so the webcam can see you guys. Real way.
I have a great idea. Why don't I stand right there behind the monitors? I think it's gotta be this way, right? We can also ask for more stools. So right here? Is there any way that we could get 2 more stools?
2 more stools?
Yeah.
This one?
So that's 2, maybe 4 more?
Let me see if I can locate it.
Yeah. Didn't tell me that. Which is what watch videos or
If you're not drunk, because if you're drunk,
I'm uncoordinated. Me with the uncoordinated. Can we leave the Costco? What do we do now? Do we go back to our hotels and hide and build it? Says how big you are.
I just didn't give myself a lot of time to pull one out from this giant loop of patch cables.
They're custom.
That is like a Libra of love right there. Nobody will have it. Fine, yes.
Yeah. You don't have.
Do you want to make sure things are working? Yeah, we're just having some troubles with that patch cable, so we're going to replace it.
I'm not plugged into anything over here. Patch cable wise.
It's just for the neck.
Okay. Things not like the other.
I like that one.
I think this is that the one?
Yes, thank you, sir.
Okay.
Put that down here for a second. I'll just take the whole thing. Thank you.
Ding.
Because that's a bit too short. Yeah. I mean, if it's potentially causing problems, we don't want to.
If there's only one cable, you know which one to use. If there are 2, you're not quite so sure.
Oh yeah. Well, if they're both, if the same problem with 2 cables, then it's not the cable. Is this gonna work for you?
Yes, totally.
Okay.
Stay there anyway.
And this will be separate. Now we'll see how they're doing in the control center. See if they still have an issue with the network.
Is someone going to tell me when I should start and if I should not yet?
I'm going to use it right now. Communication game.
While we're waiting for everything else to start, what's everybody see today that they thought was fun? This is clearly not the first talk, it's the last talk of the day. What kind of cool stuff do you see? You know, pick on somebody, pick on
Well, there was this one guy doing the elaborate talk and overreaching the sway bar, and he was amazing. The sway bar. It's my talk. I gave that talk.
So what does it like to sit in the front of the room? Anybody see him? No, see something else?
Yeah, we saw local AI, building AI locally, you know, with your own Linux kit. Instead of building Linux, you're building out of components, Linux components and server components to build your own local AI. So instead of having to pay to run it in the cloud, you can have that at home on your own kit.
On significant resource machine or a little lighter?
The example he was given was even on an 8 gigabyte or 8 gig
There's an
video.
It's pretty light hardware.
Yeah.
But it was.
I wasn't able to get into that panel, but we, at least in the foyer outside, there were like 4 or 5 of us that were all chatting about, like, one guy was demoing what he was doing for kind of local models, even on like a laptop without a real GPU, and just kind of for what performance you could get with some of the mini models in Oklahoma. So I'm kind of curious to watch the recording of that one.
You're saying if you got 48 gig VRAM, you can really do some pretty impressive stuff even at home. You need like a nice 130 watt equivalent bulb of electricity to power it.
What else people seen?
I got a Thor device.
Yeah.
NVIDIA put a 128 gig tiny ARM system, 14 cores. Not that tiny, but yeah.
You brought one for everybody?
I did not know.
Gosh.
Yeah, it's interesting. I'm not very familiar with the process of running all of these LLM things and making it work, but I have like 6 of them now, and I'm going to try to put them into a cluster and do some things.
So who is coming back tomorrow?
Oh yeah.
Everybody?
Hiking.
You're hiking?
I think something, like not specifically the talks themselves, but something I always get out of them every year is just learning about some little tool that everybody else has been using, but I have no idea that it exists. It's,
I'm so behind.
It's great. I have, you know, like 4 pages open on my phone to make sure I research when I get back home.
For me, that's DRM. I'm going to take the opportunity to advocate for a tool I just learned about.
Teach us.
DRM, DIRENV. It's just it hooks into your shell. When you go into that directory, it sets up environment variables or paths or stuff specifically for that directory, so you can throw it into a project, include some like scripts and stuff, so they're always executable, or like always kind of load my Node.js binaries that are installed in here. And when you go out of that directory, they're out of your path.
That's great.
Completely.
Does it do that when you're in somebody else's directory too?
You have to, I know where you're going with this. You have to run direnv allow before it does anything.
I remember the days of everyone in my Unix cluster having dot in their path at the beginning. And so I had all these directories with ls in it. And their Xtank ran much slower than my Xtank. I can understand. All right, 5 minutes. Anybody else got cool stories from today?
It's not.
We're all tired.
Yeah. I can finally replace my Ubuntu in 10 years. That's good.
What is?
You don't have to.
Well, it's really dirty.
Was it the only one you had all these years you kept using it?
Yep. Yep. It's a really dirty orange Ubuntu in here. It doesn't really say Ubuntu on it very well anymore.
Did you use it as a lanyard or also use it for like in the backyard with the house or something?
That was like my car keys, so it lived on me. I finally retired it a couple months ago because it was getting too gross. It did pretty much, yeah. That's my orange Kia too that I have for a while too. It's pretty neat.
Is anybody else giving talks here? Does anybody else want to give talks here or at other conventions? And what advice? We have at least 2 people who've done them in this room.
C-Like is doing this thing sometime soon.
I believe their call for participation just came out yesterday. Yeah.
So I might send them something. I haven't done a talk before, but I've got all of this experience, so I should be able to.
I just carpet bomb applications. That's like every conference that seems cool, and then 1 or 2 usually says yes. I just go to those. So it's usually pretty easy. So.
Which conference were you talking about that you were looking at?
Oh, CGL.
Seagull?
Yeah, Seagull.
Oh, yeah. I heard of that.
Down in Seattle.
Yeah. Haven't made the trek yet, but eventually.
Where are you from?
Here.
It's not that bad.
It's not that bad. I go down there for concerts, so I might as well go down there for Seagull.
Seagull is why I'm here.
Yeah?
That's where I heard about this.
So you go that direction?
Yeah.
Well, this one definitely started first. This one like set the bar really high.
Yeah.
And Salt and everybody else at Seagull were like, we should do it down here. This could be a lot of work. And it really is, but they do a great job.
This space is perfect for this event, just the Bellingham Technical College. This is an awesome place to have an event.
Yeah, I'm really glad they let us come out here and take over like 3 buildings almost. It's crazy. We're just blathering because it's not time yet.
Okay.
Am I supposed to stand there now?
No, I was we were seeing unsupported signal and trying to see if we needed to fix things.
They were probably kicked in.
Gotcha.
Let me get it in my finger.
Oh, cool. Okay. Sweet. You can keep chatting. It's fine. Just want to make sure.
So I'm just going to ask you, what is
Yeah.
DropZone AI?
That's where I work, and this is not a marketing spiel.
Yeah, I know. I just was curious.
We are a Agentic SOC Security Operations Center tool. So we are the tool that you would use if you want to have your actual SOC analysts have the fun part of like doing shit as opposed to researching the problems and all that boring part that no one really likes. And I'm not in the marketing department, you can tell. Let me know when we should go. The QR code here will work. I don't actually have these slides posted on the website, but it'll be an hour or 2 when I get around to it. There's also a QR code at the very, very end as well, so it'll be all there. You don't need to take notes if you didn't want to. Do we know when we're going to be actually getting these things streamed?
The live stream should be going on right now. The recording that goes to YouTube should be soon, TM.
Sweet.
I think we need a little bit of time after the fest because it's one big video file, so we cut it up into each of the videos and put it on the YouTube. You're good to go.
Okay, good morning, good afternoon, everybody. Welcome to, it's always morning. I normally just always say good morning. I'm Bry Hatch. I'm the head of infrastructure and security at DropZone AI, and they let me come out and do talks from time to time, so I'm not just working and hanging out with all my team and doing neat stuff. This talk actually kind of came out of a number of real events at different places I have been. I want to talk about how we, as engineering geeky people, talk and how sometimes it doesn't come across the way that we might think it will or might not want it to do. So I'm going to start off with a couple examples from the real world. Now, these are obviously fake images, but login phase 1. What is this? This is your standard username, password, login screen, right? I was at a place, we had a product, we wanted people to have to log in because user identity, RBAC, identity is important. Not everyone should be admin. So username, password. Couldn't be anything wrong with that, right? Everyone's seen those a million times. We get a complaint from a customer who's like, I cannot log in. Every time I go there, I have to reset my password, I get logged in, and the next time I have to log in, it doesn't work anymore. We're like, what's going on with that? I got a password manager and everything. It should just work. Oh, it's probably a password manager problem. Maybe there's some JavaScript issue between you and us. We can work with that. Let's just do a screen share and see what's going on. And so this guy who seemed really smart, couldn't get in. We go and we watch him. He types in his email address. He types his password, or rather has the password manager do it. It's 128 characters long. And we're like, okay, that's really secure. We only supported 64 characters. The JavaScript would essentially truncate you as 64, and so he was typing all of this, it was dropping it off, and it was working on the input phase, but not subsequently. So password reset took all 128, login screen took 64. He was never typing the right password. So, oops, totally our bad on us. Easy fix, little egg on our face. Another example. This is story number 2. Different place. We got our users logging in. They're using our app. It's all great. But they complain like every time I go to log in, I mean, other than the first one, but every time after that, I go to log in, it's sending me through the dang CAPTCHA screen. We're like, why? We use a third-party identity thing. Maybe they're really anal intent. Our first thought is, well, what would make you look like you're having CAPTCHA problems? Why would they do that? Well, it could be, looks like there's hinky traffic. You must all be in the same office, right? And there's one external IP address for all of you, and it looks like you're hitting it too much. And they're like, we all work at home. Okay, so that's not it. Are you all working at the same home? No. You're all working at the same Starbucks? No. Okay, trying to figure out all the different things could cause them to be constantly capturing every time they log in. Go for it, yeah.
Did you check that they actually weren't Skynet?
They were not actually Skynet. They were, in fact, to our knowledge, human. And so they're constantly picking curtains and saying which of the things are couches and which of the things have bicycles. And they're like, we are so tired of this. And we're like, we could not figure it out. We could not repro it. No matter what we did, when we did try to do nasty stuff, we didn't get back the CAPTCHA either. We talked to the third-party identity system. We're like, hey, what could cause this? And like, I mean, denial of service, any of the standard stuff. We're like, well, none of this sounds like it should be happening organically. So no idea. Well, so we did screen share with them too. And every time they hit log out, it would do an infinite redirect from the identity system to our device. To this identity system and back and forth and back and forth. And eventually you get that this page isn't working thing inside your browser. And when we look at, in Chrome Developer Tools, 1, 2, 1, 2, 1, 2, back and forth, back and forth, back and forth, back and forth. We're like, yeah, that's bad, that's dumb, that's inelegant. Why did we not notice it? We never hit log out. Why would we log out? Like, who even built that button? Okay, we built that button, but who uses that button? So that was a surprise to us. Now, we had lots of automation. We had Playwright testing that the login, logout procedure worked, made sure that the cookies were invalid, made sure that we were secure. It never bothered to tell us it had an infinite redirect, but it said that the session was valid. It was properly telling us things are working fine. It just wasn't giving us a UI perspective that the UI wasn't looking good, and we never logged back in again from that same set of cookies. We did a brand new, fresh Selenium or Playwright login, so it was starting off afresh, and so we didn't get gently wafting curtains. Please, dear human, tell us which ones we care about, right? So at the end of the day, we had cranky users, and then we had the cranky engineers. They've got problems. We don't want them to have problems. We want them to have a happy, wonderful experience. But we've been pissing them off. First case, we were truncating their passwords stupidly. Easy fix. Second case, the URL redirect from IDP back to us was broken. Again, not security problems in any way, other than accidentally, violating the A of CIA. The availability wasn't working for the first one, the password problem. So we failed secure, but we failed. We failed the users. So how should we describe the problems we had here? We want to tell our customers, hey, things are fixed. Here's the problems it was. We want to make sure that we're open, transparent, as honest as we can be. We also want to tell all of our support people and our customer success people, if a customer is asking about it, here's what you can say. If we have a joint Slack or whatever room between people, how do we communicate that? So some good ideas. Actually, anybody want to tell me what you would do before I show my good ideas? How might someone communicate this to customers?
I would just have like an RSS string that has releases, like documentation about good, bad, everything that happens in a release, and things that are fixed on the issues that you identified.
So an RSS change log between versions. What words might you use on that change log? You or anybody else?
Breaking change, I suppose. That's probably important.
Breaking change for the password truncation problem?
Anything that maybe somebody got, depended on it for a feature. I just mean in general, not these things that you.
How about for these specific ones? Anybody want to give me your customer-facing marketing speak? Way back there.
Updates and fixes.
Updates and fixes.
Improve reliability of authentication.
Improve reliability of authentication.
The login screen works now.
The login screen works now.
Show them in the assembly where things went wrong.
Show them in the assembly code where things went wrong. Anyone like that plan? Probably not. So here are two things we could have used. For the first one, we fixed a problem with extremely long passwords. A new limit is 128 characters. We have contacted the affected users and confirmed the fix is functional. Right? We did a little workshopping. That explains the problem, explains why it was there, and explains how to fix it. The second version, we identified an infinite redirect loop in our logout procedure that resulted in a Chrome error message and could additionally cause you to need to perform a CAPTCHA at your next login. However, at no point was there a security issue, as the logout was completed successfully on both server, IDP, and browser. We're telling you we did something wrong, what the effect was for you, but we failed secure. So you can still feel like we're a decent company, we did the right thing. And so we're being open, we're being transparent, we're being useful in our communications. Now, here's where things went funny. One of these happened to be right around an all-company event. We're sitting around getting our food in line. And we got engineers, we got salespeople, and we just figured this out during a break. Like, we finally figured out this stupid redirect problem. We finally figured out this CAPTCHA problem. Somebody in that line in engineering, and it might have been me, I honestly don't know. I have no idea who it was, but it could have been me, said the following. My God, if we can't even log out users correctly, can we even call ourselves a security company? We were not using the right words in this case. Salespeople, marketing people were surrounding us. Customer success people were standing around us going, oh my God. Is it really that bad, they wonder? Have we been lying to our customers? Do I need to find a new job? Do I need to work on my resume right now? What have I gotten myself into? We had freaked out coworkers because of our flippant engineer speak. We had hyperbole, right? Was it actually that bad? No. But it's more fun to talk that way sometimes. And that's often how engineers speak. That's how we communicate. That's how we laugh off the problems that we ourselves created, because we are fallible. And so that kind of humor feels good to us, but not to the person who's just trying to get their, chimichanga and thinks, oh my God, I need to find a new job. We're all going to be tanked by tomorrow. Okay, I want to test you all. This is some Python code. It's completely valid. Nothing wrong with it. Does anybody like it? Does anybody dislike it? Are there any things in here that you might change?
Meaningful white space was a mistake.
Somebody doesn't like Python, back to Perl with you. Anything else that you like, dislike?
This documentation is completely shitty.
There's
Complete lack of it.
There's no documentation of any kind. Anything else?
Does it even sum even numbers?
Does it even sum the even numbers? While I is less than numbers, if the number is mod 2 equal to 0, so that's finding all the even ones, then it total equals total plus numbers I. So it will add in each one of those even numbers as it goes.
So why are you indexing on numbers instead of just ranging over it? Or like for I in whatever?
So you don't like the fact that this is using a while loop, using an I index. You'd rather use the for primitive.
The reason I don't like that is because it's bad.
It's janky shit.
For those remote folks, he said, the reason I don't like that is because it's bad.
Yeah.
Why is it bad?
Because that's not Pythonic. You're supposed to use not use indices. You're supposed to treat the iterators and stuff there.
This was probably written by a C programmer who is used to working across arrays and having it indexed into them, and it doesn't feel Pythonic. Probably if people look a little further down here, they might say total equals total plus numbers I, totals plus equals. There are a bunch of things in here that if you've been using this language for a while, this looks poopy. I just don't like it, right? So let's see. No type hinting for those newer folks. There's type hinting in Python. Why do we have a counter, as you were just calling about it? Why don't we do for num in numbers to iterate across that instead? Total plus equals num, and that whole last I equals I plus 1 could be I plus plus, but we don't even need it all. As engineers, if you sat down with that first code, or if you were doing an MR, you'd probably look at the person and say, I don't like it, just fix it. It offends me to the core that you would write this code this way. Urgh. Grumpy, grumpy, grumpy. This could be written as one line. It's kind of low here on the screen, but you can say return sum and do a list comprehension. This whole thing is too noisy. You could spend lots and lots of time in that RMR teaching that other person why what they were doing was wrong. And you would feel holier than thou, and we would make sure that everyone's using the same style. And that's actually a good thing. But it is, again, one of those kind of weird engineering mindsets of code purity, code consistency, that helps us write good, consistent code between the team, that makes it easy for me to jump into a piece of code and have it feel familiar and use the style of my company or my team. That is a good thing, but it also tends to make us think about black and white, zeros and ones, true and false. It's good or it's bad. It's all good or it's horrible. How can we even be a security company? It leads into that hyperbole. I like to think about an engineer's mind this way. Do you see that big blue section? That is the stuff that drives me crazy. It is 1% of the code base. And the stuff that doesn't drive me crazy, that's the 99%. I don't think about that at all. That 99% of the code that works great doesn't bother me. That's not what's in front of my face. The thing in front of my face is the thing that is driving me bonkers. That one tiny, tiny edge case makes me incensed. Again, if you're talking to others and you have that same incensed feel come out, they get confused because they think this one horrible thing, which is not horrible, is representative of the rest of the code. So let me give you some specific phrases you might have with other folks outside of the engineering team, outside of the engineering mindset, and let you hear kind of like the translation buffer they have. You say, this whole thing is a house of cards. Again, we love hyperbole. What do they hear? I need to update my resume. What you really mean is, there's a 1 in 56 million chance that a single bit flip could impair my analysis. It's no biggie, but you phrase it horribly. This is a massive hack. Who said that? Who's built massive hacks? More than would raise their hands, honestly. They think it's illegal, dangerous, it's going to cause instability that's huge. We mean it's clever, but it's inelegant. It should be looked at later on. It's a massive hack. We are aiming for the end of the quarter to deliver this product. What is marketing here?
It's going to be ready at the end of the quarter.
It's going to be ready, and I will make the PO contingent on feature delivery. You just signed in blood that it's going to be ready because you said we're aiming for it. What you mean is it might be harder than expected. It might slip. We're not sure. But we're aiming for it. They hear sign on the dotted line. We can tell our customers now. We can post it on Twitter.
So I can multiply by 4.
Some people just multiply by 4. Some people refuse to talk to sales for that reason. That also works. It's a straightforward fix.
Who says that?
It will remediate in a few minutes.
Yep.
Straightforward means I know what to do. Doesn't mean it's fast. It means I know where the problem is. I know where to hit it with the hammer, but I hit it with the hammer, and then I test, and I test, and I reproduce it here and there. And so straightforward fix still could take hours or it could take days. We need to refactor this component. What do they hear?
Overhaul?
All forward progress is halted while the engineers are making meaningless code changes. They're just having fun building a new framework, right? We mean it's making a rattling noise and parts of the car are going to fall off. So we need to do that now before the engine completely falls apart.
Then it's a house of cards at that point.
There's a house of cards.
To be fair, sometimes they're right.
Sometimes they are right. Sometimes it's like, ooh, I've always wanted to do this. It's finally my chance. I can
fix it with the hack.
Let me fix it with a hack. So what can we do when we're interacting with others? You do need to say what's true, but you also want to be clear about what is not problematic. When you say this is broken, make sure you say what's not broken. It could be a very small broken bit and a large not broken section. Normally we optimize our code for cost or for speed or for low memory usage or something like that. In speaking, optimize for interpretation. That might mean foregoing accuracy, but making sure they understand what is important for them to understand. Talk about the scope of the problem. Don't talk about implementation. Don't talk about the mechanisms. They don't care for you to show your work. They don't want to know that this class needs refactoring to X, Y, Z. They need to know, what does this do for me? Is this going to be landing on time? Is it going to be causing problems? Is it going to cause instability? Is it going to cause new changes? Do customers need to do something different? They don't need to know the under the hoods. Don't justify your job. Don't justify the work. Give them just the info they need. If it sounds dramatic, try again. That's just going to make it sound much worse to them. They're going to freak out. So a good example is say, the issue is this. It affects this thing and it doesn't affect that. Start with that. And if they don't need any more, shut up. Leave it. They've got what they need. So similar ideas. Avoid jargon, avoid acronym soup, avoid terms of art that they don't understand. If you start talking about mutexes, you have lost the thread entirely, right? You have to talk about what makes sense to them, explain like I'm 5. Or use your business speak words. If you can throw synergy in there for bonus points, go for it. In some cases, yeah.
What are PMs, SEs, and TAMs?
PMs could be project manager, product managers, project or program managers, any of those versions.
Oh, so those are acronyms?
Those are acronyms. Well said, sir. You should route through your PMs and other acronyms. Oh, nice. SEs, sales engineers, TAMs, technical account managers. Often, if you are on the engineering side, it's good to route that communication through those people who are used to being the glue between the engineering geeky teams and the non-engineering geeky teams. They will have that translation part for you. Until you feel more comfortable, it's often good to route through those folks because they will take all of your brain dumping and distill it into the smaller version that needs to be communicated out. Try not to overwhelm. When you've got a million things, break it down into 1 or 2 or 3. And that's maybe all you need. And if there are a bunch of things that you're just hand-waving away or not even bringing up, you know it's going to take X amount of time, and in your brain you can have all those things listed out. You can create JIRA tickets for all those. They only need an overall scope, the overall process. It's going to take this much. We're going to do a beta on this date, and we're going to hopefully get it out the next day. Last on this one, sometimes it's helpful to say, now that I brain dumped this to you, can you tell me back what you think you heard? Let me just make sure that we're on the same page. Because I'd hate to communicate this wrong and have you make a decision based on something where I confused you. Again, you're kind of putting it on yourself. You're not telling them you might have heard me wrong. You're not smart enough. You're saying, I might have communicated in a way that wasn't the language you needed. Ask them to feed it back to you. This is something that I would suggest for folks that is kind of some rules I've come up with that aren't necessarily for different departments. They could be internal, they could be for your manager. But things that I have found are useful to keep me from stepping on my toes or saying something stupid. Does it need to be said? Do I need to say something at all? Especially if you're kind of annoyed at something. You want to tell your manager, you want to tell a coworker. Do you need to say it at all? If not, maybe you shouldn't. This is good for just like team harmony. If it does need to be said, does it need to be said by me? Maybe it should be said by somebody else. Maybe I should talk to my manager and say, hey, so-and-so is doing this. I think they need to be communicated that this is not the best way it's working out. Maybe route it through somebody else. Maybe you shouldn't be talking to that person directly. Maybe it comes from somebody else with better authority, a higher name, a lower department, whatever. The other one is, this needs to be said by me right now. Often, I have put my foot in my mouth because something needed to be done immediately in my current brain that would have been much better if I waited till tomorrow. There's really value in saying, do I need to get this out the door right now? This might be helpful with your spouse, kids, parents. Do I need to say this right now? Can I wait till I've got a little bit more calmness in my demeanor? So this is good, not just at work. The other one that I really like is, if it's really satisfying to say, you probably shouldn't say it. If you've been waiting all year to be able to say this thing, it's going to come off wrong. So if it's really satisfying, you probably shouldn't say it at all. So overall, engineers, they're not pessimists. They're safety inspectors. They're the people who are trying to make sure that things work well. For them, language is like code. It has to be super precise. It has to mean what it means. It has to be as exhaustive as necessary. To non-engineers, that's not how they work. Language is a way to communicate just the meaning and not the implementation. It's supposed to get them from some sort of feeling toward an action. It's supposed to get them to know what to do. It's a very flipped version of how engineers often think. Anybody have cool examples of things they've done well, or cool examples of things they have done wrong when it comes to communication?
My sister bought a ARM-based Windows laptop. I told her, why did you do that? And I went off to the deep end of here's the things you can't do on ARM that you could do on an x86 machine. And she was like, I just want to open Word.
For the remote folks, sister bought an ARM laptop, and the response was, why'd you do that? Here are all the reasons not to. And she's like, I just want to open Word. I want a simple thing. And yes, you dug in because you know all the reasons a horrible idea. Just like when my kids are like, I want a laptop. I'm like, well, we're going to get a Linux box. And they're like, I just want to be able to get my Neopets. I just want to be able to go in a browser and play with my donkey things, right? Okay, you're right. That's right. Any other good ones?
When I worked at a big co, I told my manager that some people only do things to make it look like they're doing work at the company. And I said his name afterward, but I won't say that here.
Good job editing. Editing while you're talking is an important skill, even here. Any other fun ones? All right. Well, I really appreciate the time. Think about how you are presenting your information. Think about how you're being perceived. Yeah?
Well, I didn't mean to interrupt, Rob. I was going to ask, so most of what you said I think is fine, but what if the topic has intrinsic complexity? Like you can't break it down to two little bullet points that are nice and fit in a fortune cookie. You need some, there's intrinsic complexity, and you have to present it to people who wouldn't understand said complexity.
I know what I think. What do other people think?
I would say what's the outcome, or what's the big picture? Like, what's going to happen? Like for me, just being somebody who actually isn't an engineer and sitting here, I would be like, okay, what's the big picture? What is it? What's going to happen? Why do I care about this? Tell me why I should care. I don't know. Just what I'm thinking.
Why should you care? Somewhere it's on to that. I see another one.
Yeah, what I've done in situations like that is I will, if I can get them to ask me questions, because I don't always know what they care about, but if they ask me questions, they're telling me what they care about. And so then I can try to give, plain English answers to the questions that they have. But another thing I've done is ask the person just straight up, like, how much do you want to know about how this works? Right? Because the answer is usually not very much, right? What they usually want to know is like, what is not going to work while this problem exists, right? What do I need to tell so-and-so in this department, or what do I need to tell, our customers in this state or that state, to expect while we're working on this, you know, and then, and, you know, if you kind of think about it that way, I think it kind of, like, even when the answer is, even when, you know, we would think about things of like, in this very technical and precise and complex way, like, the outcome is, there's this thing that's not gonna work, that usually does, right? And it's not gonna work for a day or two, or however long it is.
Yeah, I'll follow up a little more on that one. I often will say, if I don't know the answer right now. I know this is what's currently broken on the ship, and I'm gonna have a better answer in X number of hours or tomorrow afternoon, and you're just gonna have to let us figure out. Until then, this is what's going on. Please give us some time to figure out the next part.
It's not immediately related to what you did, but I'd love to ask the question, what is your understanding of X? For something that I have I feel a pretty reasonable understanding of, and I'm wanting to communicate something back to them. Because I know kind of where I need to start, and in how they explain it back to me, I know the terminology that I need to use to communicate back to them in a way that they would understand.
Mm-hmm.
I think I would also, like, I like all of these answers. I would also add, it's hard to do. Like, it's a skill to practice, and you know, like learning any new language, learning to better explain technical concepts with non-technical language. You're going to do better if you have a project to apply this new language to. But your first attempt is not going to work well. It's a thing to work on over time, and honestly, I'm kind of okay at it now, and that has gotten me a promotion.
Did anyone notice what I did when you asked your question? You said, what do I do when I have too much information to convey to some other person? And I didn't answer it. I started talking to my friends. I started talking to my coworkers. I brought in other people before I talked to that person. And so leverage your other engineers or your acronym soup people, the PAMs and the TAMs, talk to other folks. Or for that matter, take the problem statement, everything you know, throw it into AI and say, how would you summarize this to person foo? Use other tools and resources. Other people will help you out too. Yeah.
How would you operate in an environment where you have to get technical things done, but non-technical people want to drive the ship?
Who's been in that situation?
Every day.
In what way do they want to drive the ship? There are different ways I've seen.
Not like from a, hey, we want this big, shiny, cool product, make it now, but like almost getting down to the point of like talking about the fine details with not really knowing what they're talking about. So like they think they know what they're talking about, but you have to kind of say that's not reasonable, or that's not practical, that's not possible. And you have to say things that are like, if we go your route, we're going to set the house on fire. We need to steer the ship, but also say in a way that's not going to make it seem like you're downing them or anything.
Different teams can do this better or worse, but I usually find it comes down to roles, responsibility, and authority. Let's say we're designing a thing and somebody has to decide where they want the login buttons and the widgets to go. If there is one person or one team that is responsible for deciding where it goes, which may be different than the team who decides how to implement it, then if I say, I want the button over there, but I'm not the decision maker, I can only ask the decision maker and try to convince them that my way is right. And if they say, no, it's not, and we're going to put it in the left side under the hamburger or the right side under something else, they get to make that decision. Then the implementation team might say, it will take us 5 weeks to put it under the hamburger because of some weird framework thing. And then they'll say, I'd rather have it now. Okay, fine, we'll put it over there because from an expediency standpoint, it makes more sense. But having an authority who gets to decide from an implementation standpoint, this is what's acceptable. From a user experience standpoint, this is what's acceptable. From a timeline standpoint, maybe that's at the business level. Different authorities exist for these components of it, and trying to break that down, there's a thing called a RACI matrix, responsible versus accountable versus consulted versus informed. that you sometimes can do for all different types of decisions that need making in a project. And you put little X's about who is actually responsible for the end result versus who is just informed this is how it's going to be. Those kind of frameworks feel like a stupid business thing, but in dysfunctional groups or less functional groups, it actually could be really helpful.
What'd you call that?
RACI, R-A-C-I.
R-A-C-I.
I'm responsible, or I'm accountable, or I'm consulted to get information, or I'm just informed about what a decision is. And you break up all the different things that can happen, and everybody gets an X somewhere. There's always one R, one A, one ACI. And it can help when you don't know, because it kind of forces you to decide on a particular question basis. Who do I ask? Do I always ask Allison just because she seems to always be the smart one? No, you figure out where Allison is and isn't.
Are you?
I was born with you.
Okay. Are you saying that when I'm debugging code with my coworker, who I have a really good relationship with, we're both geeks, engineers, I'm not allowed to say this code is janky as fuck and it's going to fall apart any day now?
Who else can hear you say that?
It depends. It depends. There are plenty of people who would love to hear that who are not in engineering, and they will laugh their butts off, and they'll be great. Know your audience. I've been using generalities here, right? I've lumped all the marketing, I've lumped all the sales, I've lumped them into their own buckets of not engineering geeks. There are plenty of them who are engineering geek brains. There are plenty of engineers who could not listen to you say that, and they would think everything's going to break. Know your audience. One of the first things I do as a manager when I get new people is I say, hi, congratulations, your first day. When I communicate with you, here are things that you could either love or hate. I want to know which ones you like. Are you the kind of person who wants to hear about all the things we're going to be doing over the next 2 years, or do you need to focus on what's happening in the next 2 weeks? And so I tailor how I work with each individual person based on what works best for them. So know your audience so you can figure out, are they willing to hear me say, it's all janky? Or do I have to use my big kid words? Way back there first.
So, as the technical consultant for my entire family,
who also is IT for everybody to know. Yeah.
How would you suggest explaining to your mother the difference, who is, let's be clear, doesn't know the difference between a touchpad keyboard and this regular mechanical keyboard and a memory? That is like, is it a keyboard? One is a pressy one, the other one is a touch one. That's just her level of understanding. How would you explain to her the best choice of a new laptop for her? Considering she needs a system, but she knows nothing about her requirements.
Has anyone heard the phrase, the customer is always right? First of all, it's not meant the way we usually think of it. The customer is always right about their preferences, not about everything. Like, if I personally like green versus blue, then green is the right choice for me, right? So decide what is important and what is not important. If they want to have the little mouse, the little button, if they want to have a trackpad, work with them. Don't try to give them what you want. Don't make your kids use Dvorak keyboard even though you're a Dvorak user. I know it's better. I've been using it for ages. It's so much better. I'm fast. I don't have RSI anymore. They need to be able to go back and forth to school, and they're only going to have QWERTY. So I know I'm right. Y'all are stupid if you're using QWERTY. I'm not going to force you to use QWERTY. That's a dick move, right? So you're wrong when it comes to mom, what she needs. Figure out how you can get close enough to where she is while preventing problems later on. If she's like, I only need 100 gigs of RAM, or 100 megs of RAM, you're going to upgrade it or something more than that, right? You're going to find something that's going to scale for the amount of time you need. Define the problem well enough. Figure out what is a requirement versus a nice to have. If she only likes trackpads, you need a trackpad computer. If she hates trackpads, maybe find one that doesn't have it, or at least you can't accidentally put your big fat palm on it by mistake. Try not to tell them they're wrong, because you need to give them something that works. Otherwise, they're just going to go buy a second device. Do you have another question? Yeah.
Well, no, I was just going to say that one of the, just as a general maybe suggestion for folks, one of the things I often reach for when trying to explain something technical to to folks whose brains are well-adjusted people, is that is I often reach for analogy. Right, I try to find something that works in a similar way conceptually in real life, that everyday things that I can try to use to get someone to understand the concept without having to understand how AWS works, right? And that's not always easy, but I have had some feedback from coworkers that, basically were like, hey, that really helped me understand the problem that we're having when you used an analogy about plumbing, right? Like, because, there's the old, the joke about the internet being a series of tubes, but, you can kind of explain it that way. It does actually work close enough for most conversations with the coworkers that we're talking about here. So, and sometimes you can make it funny too, that helps.
Yeah, analogies can fail you if someone tries to dig into, well, in a real car engine. You're like, it's an analogy, please understand, this is abstract. If they get picky pants on you, it can go sideways and then back away from it. But analogy is really helpful.
Yeah, I used a cooking analogy with my friend many, many years ago, and just the other day she was telling me about how she still remembers that cooking analogy.
What was it? What was the cooking analogy?
I wish I remembered. But as a byproduct, I'm a pretty good cook now, so I learned something actually.
Cooking is like adding salt.
I just was, as a person, I'm actually in the education field, but what you're doing is really trying to educate people on technology, right? So if you can build on what people already know, whether it's plumbing or if you ask them what they already know, and if you can build on what they already know, hopefully you know them well enough to be able to do that, then now you're really building things in their brain that they can remember and relate to, so.
Exactly. Any other questions or comments or ideas from others?
I could talk with you about this for a long time.
What are we doing right now? We're communicating. And we figured out how each other talk, but different groups talk differently. That's the most important thing I'm trying to get out of here. And you can tell if you're talking to me right now and I'm like, I don't understand the food thing. You'd pick that up. And you'll find a different way of communicating that.
So, how would you say how do you go about...
You're going to try to make me convince your mom to get a different computer again?
No.
Okay.
How would you go about by figuring out where the individual you're speaking to is how much they want you to know? Because you can of course ask them, but sometimes when you ask somebody something, the answer in what they think they want, but what they actually want is maybe way less. How would you say you can parse that out quicker?
Start with less, and don't wait till you're done before asking for feedback. Keep an eye on if they're looking at you, or if they're starting to look down, or if they're looking impatient, or if they're just waiting for you to finish. Like, look for body language, which is harder on Zoom. But if someone's looking at you, and you start talking, they just start over here and you can tell they're checking their email, stop, right? Ask for feedback more frequently. Like, am I giving you too much information? They're going to say, yeah, I lost the plot. Or, am I getting to what you're looking for? Any of these kind of follow-up questions are really good to make sure that they have a chance to answer without interrupting, because they're going to be too polite, perhaps. If you give them an opportunity to say, is this what you were looking for? And they're like, I still don't get it. Talk to me dumber. Or no, talk to me faster. Or all I care about is X. All I care about is when is it going to be fixed, or when is it broken, or what do I need to do to tell my customer it's going to be okay. And the next day, they might be completely different people. They might want something more tomorrow. Right now, they might only care about what do I do for my customer who's complaining. Whereas the day after, they might be like, tell me how it worked, because I don't get it, and I'm really interested. So even a single person could have very different reactions depending on what's going on in their life. So frequent check-ins, eye contact. EQ. EQ is hard for a lot of techies. We're used to, it's very obvious, ones and zeros. And we humans are not ones and zeros. Any other questions or thoughts?
So what you're saying is prompt the person's individual
Yeah. Awesome. Thank you so much. Thank you to all of our Linux Fest volunteers. We could not do this without you guys. Go forth, and I hope to see people here tomorrow.
Sorry for giving you a hard time about the hours.
No. That was fucking brilliant. What's PM also like? Oh, god damn it. That was, I deserved that.
Still laughing about it.
Yeah.
Forgot to ask you. How are the
By the way, watch
twins?
out for that.
I'm not going this way. I'm going. Forgot to ask you. How are the twins?
What?
How are the twins?
They're graduating in a month. They're graduating in 3 weeks.
High school or
College. I'm going out to Massachusetts. They're graduating, and my eldest, who's 26, to become a securities route. All 3 of my kids are graduating college in the next month.
Wow.
Can you believe it? It's crazy. It's
Yeah.
crazy. They're so cute. They're so smart. They're so awesome. I love them.
Yeah. My nephew's getting married in.
I'm not ready for that.
Yeah.
Definitely not ready for that already.
Well, I think it's the wrong one for him.
Oh. Well, you always need to start a marriage. That's what my wife said with the first one.
Yeah. I won't see you tomorrow, so.
Okay. Thank you for being here. What up?
Your early example about the, can we be called a security company kind of comment. Something you were saying right after that, I don't remember exactly what it was, made me think of overhearing 2 911 operators on break. The way they talk to each other and the jokes they make are not for other people.
I worked in a hospital for years. You do not want to know what they talk about when you're not in the room. It is not, it is colorful.
Right.
In a bad way for anybody else to hear. I am sure 911 operators are the same.
Yeah.
We all have our own ways of communicating and speaking, and the ways that we try to use humor to make bad situations better, and how we have our coping mechanisms.
Yeah, exactly.
And you need that, but you can only do it with the people who are on the same wavelength.
Yep.
Otherwise, it goes badly. Or somebody gets thrown into HR conversations.
Right.
I thought it was okay. No, no one would have thought that's okay.
Yeah.
Yeah, I've seen that too.
Oh, yes, okay. I get that all the time. Jesse, we need to cook. So,
I had to explain software licensing
and also
to an executive with a background in history education.
And how well did that go?
It took 6 months, but we got there.
That sounds like longer than it should
I'm being
have.
a little flippant, but
Are you exaggerating? No.
slightly. No, it came down to like, what problems are you trying to fix? What business problems are you trying to fix? And she made some decisions that I would not have advised, but we got through it.
Well, the question is it a one-way door or a two-way door? If you make the wrong decision,
Well, for
can you
coming, but I
recover?
have to lock
Or you
up
have
the
to
room.
keep going forward?
The raffle is
Yeah.
starting in 5 minutes.
Raffle in 5
That's a good point,
Tickets.
actually.
Yeah, I'm big on making
The
quick
big
decisions
one
if I can
there?
easily undo it.
Yeah, over in G building.
So what do you guys do? We are an AI tool that runs in the Security Operations Center and it analyzes all your alerts and all the spread outs and tells you all the alert mechanics that you have from the tools, what it's actually doing.